Now we are focusing on SAP. SAP SE is a German multinational software company based in Waldorf, Baden-Württemberg. It develops enterprise software to manage business operations and customer relations. The company is the world's leading enterprise resource planning software vendor. SAP is the largest non-American software company by revenue, the world's third largest publicly traded software company by revenue, and the second largest German company by market capitalization. Apart from ERP software, the company also sells database software and technology, particularly its own brands, cloud engineered systems, and other ERP software products such as human capital management, HCM software, customer relationship management, CRM software, also known as customer experience, enterprise performance management, EPM software, products lifecycle management, PLM software, supplier relationship management, SRM software, supply chain management, SCM software, business technology platform, BTP software, and programming environment, SAP app Giver for business. Here you can see SAP integration made easy with MuleSoft accelerator for SAP. SAP is one of the most commonly used enterprise resource planning ERP solutions today. However, SAP integration is a major challenge facing organizations looking to digitize business process. For example, procure to pay process. Innovation as both new digital demands for organizations today. Consumers and employees alike are looking for connected experiences no matter the interaction. This has put increasing pressure on organizations to meet the digital imperative. The truth is that most digital transformation efforts fail in today's all digital work from anywhere environment. In reality, integration problems halt or details in 85% of the digital transformations. The organization lack of alignment between their SAP and non-SAP applications like Salesforce.com. They struggle to automate and optimize their business process. The cornerstone for the agile and efficient company is a connection agile IT landscape, and ERP integration is critical to achieve this. Here you can see the SAP ECC. SAP ECC objects supported accounts, billing, documents, orders, product availability, and SAP ECC is connected to the use case 1 here. SAP and Salesforce integration. Here SAP S4 HANA, SAP S4 HANA object supported accounts, billing documents, orders, product availability, product sales contracts. Here, and it interacts with the SAP and Salesforce integration, and SAP and Salesforce integration interact with the Salesforce. Here, Salesforce object supported accounts, contacts, product availability. Here, the use case 2 streamline procure to pay. Here, the SAP HANA object supported, and it interacts with the use case 2 new. Here, the streamline procure to pay, and it's interact with the COPA, and the COPA object supported goods, receipts, invoices, suppliers, purchase orders, invoices, payments. Here you can see a Mule ESB, one of the most as one of the most widely used enterprise resource planning solutions on the market. SAP plays a central role in the most critical business processes for many companies. In order to fully automate and optimize this business process, companies need to integrate SAP with other applications within their organization. Here we are considering SAP integration with other applications like Salesforce, EPOS, e-commerce, SharePoint. Here the SAP here, including users and benefits, challenges, and new approaches. An alternative approach to point-to-point quick fixes and expensive SOA stacks is integrate SAP using Enterprise Service Bus. ESB provide a modern and lightweight standalone solution for integrating SAP with other applications, including SaaS solutions like Salesforce, EPOS, e-commerce, SharePoint, etc. Mule ESB is the only enterprise service bus to be certified by SAP for SAP integration. Mule's SAP Enterprise Connector provides bidirectional communication and works with the existing SAP technology such as intermediate documents, iDocs, business application programming interfaces, BPIs, SAP Java Connector, CEO. Coforge had proposed that and designed the service-oriented architecture SOA for developing interface services that would enable different functionalities as reusable services. Coforge integrated SAP with other applications using a low-cost enterprise service bus ESB to address all the business drivers. Here you can see cloud interacts with the Mule ESB. Mule ESB interacts with the SAP application here. Here you can see high-level architecture to integrate SAP using Mule Enterprise ESB. Here you can see a system 1 and system n interacts with the system server. System server interacts with the Mule ESB via here the HTTPS or SOAP. And here the business services and technical services and framework components are in Mule ESB. Business services are in business services. Here the technical services are in technical services here. Audit service, JDBC adapter, MC agent, SAP adapter, alert handlers, file adapter, and ActiveMQ adapters are in framework component. Here the Mule ESB interacts with the ActiveMQ via TCP or failover. Here the Mule ESB interacts with the file system via file IO. Here the files are in file system. Here the Mule ESB interacts with the SOA audit TDL and SOA here via JDBC. Here the Mule ESB interacts with this SAP system via HTTPS and SOAP. As an example, we can consider this XML for sending iDoc and sending an iDoc to SAP. Paste this code into the new Mule app in Studio to quickly load the flow for the sending an iDoc example. Change the values to reflect your environment. SAP connector 5.6 here, 6 Mule 4 here. The anypoint connector for SAP connector enables the integration for data and to and from external systems based on SAP NetWeaver. As an example too, we can consider this: add the connector to your Mule project. Add SAP connector to your Mule project to automatically populate XML code with the connector's namespace and schema location, and to add required dependencies to the project's pom.xml file. Adding a connector to a Mule project in Studio does not make the connector available to other projects in your Studio workspace. These are the steps. Step 1, in the Mule palette view, click search in the Exchange. Step 2, in the add dependencies to the project window, type SAP in the search field. Step 3, click SAP connector in available modules. Step 4, click add. Step 5, click finish. Now we are considering, before you begin here the in SAP Concur connector 4.2, To use this information, you should be familiar with SAP Concur, Mule Anypoint connectors, Anypoint Studio, Mule concepts, elements in the Mule flow, and global element. You need to log credentials to test your connection to your target resource. For software development, software requirements, and compatibility information, see connector release notes. Here you can see POM file information in SAP Concur Connector 4.2 Mule 4. Replace x.y.z with the version that corresponds to the Concur connector you are using. To obtain the most up-to-date pom.xml file information, access the connector in Anypoint Exchange and click dependency snippets. Here you can see the connecting design center SAP Concur connector 4.2. Here the one click the trigger. Click a trigger and you can create global element by selecting reusable configurations. If a global element is not needed, you can use the HTTP listener or scheduled trigger. And to create HTTP global element for the connector, set these fields here. Field here the fields here, HTTP listener configuration here. Here the field description, here the protocol selected for the HTTP endpoint. It can be HTTP or HTTPS secure. Host, the IP address where your Mule application listeners listen for requests. Port address where your Mule application listen for the request, and base path where your Mule application listen for requests. And select plus sign to add the component. Select the connector as a component and select an operation. Then configure the global element for the connector. And here the host, they enter the host name of the Concur connector. Port, enter the port on which the Concur connector is running, and default value is 443. Base path, path where your Mule application listen for request, and protocol, here the protocol selected for the HTTP endpoint. It can be HTTP or HTTPS secure. Authorization, authentication. Authorization, Concur access the token. And the to create the access token for your Concur instance, specify HTTPS : www.concurSolutions.com/www.concursolutionsnet2/auth2/ access token.ashx. In Postman, using get method to create an access token is deprecated. Instead use one of these following authentication methods to create access token: authorization grant, or password grant, client credential grant, one-time password grant. After obtaining the access token for your Concur instance, use that access token in the configuration for SAP Concur connector. Following screenshots connector. Now we are considering about Concur API availability in SAP Concur connector 4.2 Mule 4. Review SAP connector Concur reference for supported API. Now we are considering add the connector using Exchange in add connector to a studio project in SAP Concur connector 4.2. In the studio, create a Mule application, Mule project. Click the Exchange icon X in the upper left corner of the studio taskbar. In the exchange, click login and supply your anypoint platform username and password. In exchange, search for Conquer. Select the connector and click add to project, and follow the prompts to install the connector. Now we are considering retrieve a list of list in example use case in SAP Concur Connector 4.2 Mule 4. After creating a new project and Concur global element, add the new flow element by dragging it from the palette and give a name to the flow, such as get list. Drag and HTTP listener into a flow from the palette, and then double click on the HTTP listener and click the green plus sign next to the connector configuration drop down and set the host to the local host and the port to 8081. Click OK and close the properties window. Then enter the get list as the value in the path field in this HTTP listener basic settings section, and add the Concur connector to the new flow and select the get list of the list operation. After selecting Concur configuration to you decide, finally add the transform message transform to the flow, and for your reference you may check the particular get list with flow within the example XML code further down. Now we are considering common use cases for the connector in SAP Connector 5.9 in Mule 4. Common use cases for SAP Connector include unified view of enterprise resources, enable real-time integration of digital information across your business from the financial, accounting, material management, sales and distributing, and customer service to make data-driven decisions that optimize core business process. Data synchronization, sync SAP data with your business applications such as Salesforce, Workday, Marketo. For example, you can migrate a large set of accounts from SAP to Salesforce to broadcast changes in the organization from SAP to Workday in real time. Sales order automation, automate sales order processing between SAP ERP and CRM such as Salesforce. BAPI support, discover BAPI and query BAPI RFM enabled functions modules, so execute BAPI's functions. IDOC integration, send and receive IDOCs from SAP, import IDOCs or transform SAP objects to and from XML. Now we are considering upgrade steps in upgrading and migrating to SAP Connector 5.x Mule 4 in SAP Connector 5.9 Mule 4. Follow these steps to upgrade. Anypoint Studio, create a Mule project. In a Mule palette view, click search in Exchange, and in add dependencies to the project, enter the SAP in search field, and in advanced available modules, select SAP Connector Mule 4 and click add. In click finish, and 6 verify that the SAP Connector dependency version 5.x in the pom.xml file in the Mule project, where x.x is minor release and patch version number. For example, if you are upgrading to version v5.2 and the dependency version in the pom.xml file should be 5.2.0. Now we are considering SAP Connector 5.9 terminology Mule 4 in SAP Connector 4.9 Mule 4. ABAP Advanced Business Application Programming, SAP proprietary programming language and part of the NetWeaver platform for building business applications. Now we are considering configure the libraries in the Anypoint Studio. In SAP Connector 5.9 5.9 Studio configuration Mule 4 in SAP Connector 5.9 Mule 4. After installing SAP Connector in Studio and adding the connector to your Mule project, configure the libraries. Double click on the connector in the flow. Then click plus sign on the right of the connector configuration field. This screen appears. Now we are considering configure general settings in additional in SAP Connector 5.9 additional configuration Mule 4 in SAP Connector 5.9 Mule 4. At the bottom of the canvas, click global elements, then click create, then expand the connector configuration, select either SAP inbound or SAP outbound and click OK. In the click the advanced tab at the top of the global element property screen, and in the general screen set the max idle time parameter. Now we are considering link the SAP certificate to a certificate. In configure the SAP server, in configure the SAP secure communication connection with the certificate. In SAP connector 5.9 MuleSoft, download the SAP instance certificate and click it to link it to a certificate. Click the glasses icon, first icon on the left of the screen to enable the edition mode, and then double click CN equal SL above IDP. Click the download button on the bottom of the screen and enter the target path for the download. Click the import icon and enter the target path to the upload your certificate, and click the add certificate list and click the save icon. Open the command line interface or terminal window and use the SAP Gen PSC tool to link your certificate to your PSC. SAP Gen PSC maintain pk -v -a. Here the name of SAP server certificate.crt -p and name of your PSC.psc. Now we are considering configure your SAP connector. In configuring SAP secure network communication connection with Kerberos in SAP connector 5.9 in MuleSoft. To configure SAP connector, enable SNC in Kerberos. Access Anypoint Studio, select SAP in the Studio canvas. Click the plus sign next to the connector configuration field to access the global element configuration fields. Configure the Kerberos connection. In the connection field, select Kerberos, and in the general tab, configure this field: SAP system number, SAP client ID, application server host, Kerberos config file path to the krb5.config conf file using KDC address and main ream information, sso domain.lab. Key tab file path to the key tab for the SPN from Active Directory. Key tab must contain the only the entry of the principal SID ADM. If you use the existing key tab, you must remove the existing entry first. To remove the existing entry, run the following command: ktutil -k etc. to create, and you can use the ktutil command to create a key tab. Also GSS lib path static value for /usr/lib64/lib gss api _ curb5.so.2.2 when using Cloud Hub principal service username for Active Directory, in this example SID ADM, client SNC partner name, SPN name for Active Directory, in this example p:/SAP service /SAPDEV at sso domain.lab, client SNC my name service username from Active Directory, in this example p:/SID admin SID ADM. In the advanced tab, you do not need to change the extended properties because the Kerberos configuration already set them. Now we are considering add a namespace for the connector. In SAP connector 5.9 MuleSoft and SAP connector 5.9 XML and Maven support. Paste the following code in Mule in the Mule tag of the header of your configuration XML. In this example shows how the namespace statements are placed in the Mule XML box. Now we are considering at the POM file dependency in SAP connector 5.9 XML and Maven support in Mule 4. SAP connector 5.9 in Mule 4. For JCO library support, the Apache Maven pom.xml file generated by Anypoint Studio contains dependencies for Mule app. If you code a Mule app manually, include this XML snippet in your pom.xml file to enable access to this connector. Replace XXX with the version that you correspond to the connector you are using. For JCO library support, add these dependencies. To obtain the most up-to-date pom.xml file information, go to Anypoint Exchange. Then in Exchange, click Login and supply your Anypoint platform username and password. In the Exchange, search for SAP and select Connector and click Dependency Snippets near to the upper right of the screen. Now we are considering add the transform message component. In SAP Connector 5.9 example, in SAP Connector 5.9 Mule 4, configure the transform message component to convert IDOC input to XML. From the Mule palette view, select core and drag the transform message component next to the listener. After the metadata is retrieved, overlay the text of the output section of the transform message component with the following text. Now we are considering enable verbose exception logging in troubleshooting SAP Connector 5.9 in SAP Connector 5.9 Mule 4. Enable verbose exception logs to show the complete stack trace of the error instead of the default truncated output. In Studio, right click on the project and select run configuration. Go to the arguments tab and append the arguments in the VM argument section to add the Mule verbose.exception property, for example here. Now we are considering the configuration in SAP Connector 5.9 reference Mule 4 in SAP Connector 5.9 Mule 4. Here the configuration, the name type string and name for this configuration, connectors reference the configuration with this name. Default no default value required. Now we are considering common use case for connector in top SAP S4 HANA OData connector 2.6 Mule 4. Platform CRUD operations on entry types of SAP S4 HANA's OData API and process the response. Now we are considering 2.6 in what's changed in upgrading and migrating SAP S4 HANA OData connector to S2.x Mule 4 in top SAP HANA OData connector. To support the custom namespaces and connector now includes the new scope service discovery relative to path and services attribute fields in the connection types and new service attribute types. Now we are considering configure a global element in using Anypoint Studio to configure SAP S4 HANA OData connector in using Anypoint Studio to configure SAP S4 HANA OData connector 2.6 Mule 4. In your to use the global element properties configuration dialog to configure the global element for SAP element SAP S4 HANA OData connector. In your project, click Global Elements tab at the base of the canvas. In the global elements, in the global configuration elements screen, click Create. In the choose global element type wizard, expand connector configuration, select SAP S4 HANA config and click OK. Configure the following values in the general tab. In the connection drop down menu, select the connection type, basic authentication. For basic authentication, enter the following required field: service base URL, the URL of the SAP S4 HANA instance you want to manage, username, the username used to initialize the session, password authenticates the user, OAuth application connection provider, and further click the advanced tab in the configuration window and configure the following values: time zone, batch buffer size, buffer unit, response timeout, response timeout unit, and click OK and save the global connector configuration. Now we are considering add the reference namespace statement for the connector. In SAP HANA, SAP S4 HANA or data connector, in SAP S4 HANA or data connector 2.6 in MuleSoft. Paste the following code inside the mule tag of the header of your configuration XML. In this example shows how the namespace statements are placed in XML. Here you can see an XML code for an example. SAP S4 HANA or data connector 2.6 example MuleSoft in MuleSoft, and in SAP S4 HANA or data connect 2.6. Now we are considering create a batch operation in SAP S4 HANA or data connector 2.6 batch operations MuleSoft in SAP S4 HANA or data connector 2.6 MuleSoft. Place the initiate batch operation in the MuleSoft which returns the unique batch identifier. This unique batch identifier must be stored, for example, in the flow variable, so that it can be used to group the batch data operations under common batch request. Use the create change set operation to create a new change set. This operation returns the unique change set identifier which you then use in the batch create, batch update, delete entry, or batch execute function operations to add them in the change set. 3. When you complete the batch, use the batch execute batch operation and send to the batch request. The batch create entry, batch get entry, batch query, and batch execution function operations returns JSON result. However, the result of these operations cannot be read until the execution batch operation is executed. If you attempt to read the result before the execution batch operation is executed, the connector throws an exception. You can store the output of these operations, for instance, into a flow variable and access the output after the batch execute batch operation executed. After execute batch operation successfully executed, the summary is returned, which contains the basic information about outcome of every batch operation that was included as part of the batch operation. The detailed results of these batch operations are then available to read. Now we are considering SAP S4 HANA or data connector 2.6 reference MuleSoft in SAP S4 HANA or data connector 2.6 MuleSoft. Then here the name, the type is string, and the name for this configuration, connectors reference to the configuration with this name. Now we are considering common use cases for the connector in SAP S4 HANA's SOAP connector 2.5 MuleSoft. send XML request to S4 SAP S4 HANA's SOAP API and print the response. Now we are considering upgrade steps in updating and migrating SAP SO for HANA SOAP connector 2.x MuleSoft in SAP SO4 HANA SOAP connector 2.5 MuleSoft. Follow these steps to perform an upgrade. In the Anypoint Studio, create a Mule project. In the Anypoint palette, click search in the exchange. Add dependencies to project. Enter SAP S4 HANA SOAP in the search field. And in available modules, select SAP S4 HANA SOAP connector and click add. Click finish. Verify that the Mule SAP S4 HANA SOAP Cloud Connector dependency version is the one you are upgrading to the pom.xml file in the Mule project. Now we are considering configure the SAP S4 HANA SOAP config in using Anypoint Studio to configure SAP S4 HANA SOAP connector 2.5 MuleSoft in SAP S4 HANA SOAP connector 2.5 MuleSoft. When you configure a connector, it is best to configure the global element that can be used by all instances of that connector in the app. Configuring a global element requires you to provide authentication credentials. Use connector users to access the target SAP S4 HANA system. SAP S4 HANA connector supports both basic authentication and OAuth 2.0 client credentials authentication. To configure the global element for SAP S4 HANA SOAP connector, follow these steps. In the project, click the global element tab at the base of the canvas. In the global configuration elements screen, click create. In the choose global type wizard, expand connector configuration, select SAP S4 HANA SOAP config and click OK. In the general tab, select connection authentication for the connection drop down. Enter the required information for the selected connection type and click OK. Click test connection to ensure that the access credentials are correct. Click the addressing tab to configure the following values. The version and from. Click the advanced tab to the configure the following values. Discovery service enable, discovery service path, discovery service directory, unlisted services, service discovery resolution timeout, service discovery timeout, default headers, default query parameters, TLS configuration, proxy configuration, and click OK and to save the global connector configuration. Now we are considering add the namespace for the connector in SAP S4 HANA SOAP connector 2.5 XML and Maven support MuleSoft. Add SAP S4 HANA SOAP connector 2.5 MuleSoft. Paste the following code inside the Mule tag of your header of your configuration XML. This example shows how the namespace statements are placed in the XML. Here you can see an XML code for an example in SAP S4 HANA SOAP connector 2.5 examples. In SAP S4 HANA SOAP connector 2.5. Now here we are considering add and configure a listener. In web services addressing an example MuleSoft in SAP HANA SOAP connector 2.5 MuleSoft. In the palette, click in the Mule palette, click in Mule palette view, click HTTP and select listener. Drag the listener operation into the canvas. In the listener configuration, click Click plus next to the connector configuration to add the global element, accept the default, and set the path to the /WSA. Now we are considering config in SAP S4 HANA SOAP Connector 2.5 reference MuleSoft in SAP S4 HANA SOAP Connector 2.5. Here is the parameter name and the type string. The name for this configuration, connectors reference for the configuration with this name. Now we are considering common use cases for the connector in SAP SuccessFactors Connector 4.1 MuleSoft. Some kind of common use cases for SuccessFactors connector include creating and deleting entries in SuccessFactors, retrieving an entity by ID, and performing queries over entities of the specified type. Now we are considering upgrade steps in connector to version 4.0 MuleSoft in upgrading and migrating SAP SuccessFactors in SAP SuccessFactors Connector 4.1 in MuleSoft. In Anypoint Studio, create a Mule project, then Mule. In the Mule palette view, click search in the exchange. In add dependencies to project, enter the SuccessFactors in the search field. In available modules, select SuccessFactors and click add, and then click finish and verify SAP SuccessFactors connector dependency version 4.0.0 in the pom.xml file in the Mule project. Studio updates the connector automatically. Here the configure a global element for the connector. In using Anypoint Studio to configure SAP SuccessFactors Connector 4.1 in Mule for SAP SuccessFactors Connector 4.1 MuleSoft. When you configure a connector, it's best to configure a global element that all instances of that connector in the app can use. Configuring a global element requires you to provide the authentication credentials that connector requires to access the SAP SuccessFactors system. SuccessFactors connector supports the basic and OAuth 2.0 authentication method. To configure the global connection of SuccessFactors connector, follow these steps. Select the operation in the Studio canvas. In the configuration screen for the operation, click the plus sign next to the connector configuration field to success global element configuration fields. On the general tab, connection in connection, select authentication method configure basic or authentication. You can reference the configuration file contains anti-style property placeholders recommended, and you can enter the authentication credentials in the global configuration properties. On the advanced tab, optionally specify the reconnection information including reconnection strategy, and click test connection to confirm Mule can connect with the specified server, and click OK. Now we are considering use a query as a filter in SAP SuccessFactors 4.1 additional configuration information MuleSoft in SAP SuccessFactors Connector 4.1. To configure the query operation to perform queries over entities of a specified type, follow these steps. Select query operation on the canvas. In the general properties tab, select query value for the filter drop down. In the value field, enter the following operations using the format described in OData URI convention sites item 4.5. Select the entity set name in the list. Following some example queries here. Start with username Mule EQ true, and start with Mule username JA EQ true, or start with username N3 EQ true, username EQ Mike. The Mule value is only used to filter field. The actual query is built by the connector. Now we are considering add the namespace for the connector in SAP SuccessFactors Connector 4.1 in for XML and Maven support in SAP SuccessFactors for Connector 4.1 MuleSoft. Paste the following code inside the Mule tag of the header of your configuration XML. This example shows how the Mule statement are placed in the Mule XML block. Here an XML for creating a query. in SAP SuccessFactors Connector 4.1, in SAP SuccessFactors Connector 4.1, Mule4. This is a XML for query operation flow. Now we are considering default configuration in SAP SuccessFactors 4.1 reference Mule4 in SAP SuccessFactors Connector 4.1 Mule4. This is the proper parameter name. Type is string. The name for this configuration. Connectors reference the configuration with this name. Now we are considering SAP S4 HANA setup guide in setup guide. The configuration in S HANA. In S4 HANA in SAP S4 HANA setup guide in prerequisite in consumer goods in cloud information model in accelerators. To make the necessary configuration in S4 HANA, create a communication system with the system in the responding Fiori app. This is communication system represent the external system that will consume S/HANA consume this S4 HANA cloud SOAP service. In this example, it's named com_000_9_SOAP_out. For the business system name, for the business system name, use the name of the system ID in the hostname field. Enter the name of the hostname and of the Mule application deployed in the Cloud Hub. If you don't have it yet, you can either enter the mock URL and then modify it later. Create a user that will be used to connect the Cloud Hub app using for sending product information in the cloud outbound scenario. This is necessary even though the Mule application does not validate the user. We used any user for cloud outbound. Use the communication management Ferrari app to create a new communication arrangement. Create a new communication arrangement. Select the communication scenario SAPCOM009 and then define a specific name for the arrangement SAPCOM0009 SOAP. The communication system field. Select the communication system created in the previous step. In the outbound communication, select previously created user and configure the product master replicate from the SAP S4 HANA cloud to client and include the following settings in the to make to note the path /SAP /BC /SRT /SCS /SAP /product MDM bulk replacement bulk replicator request, because that will use this path to configure the Mule application SOAP endpoint. Set the service status to active and replication model anytime. Replication model 1 equal I initial. The output model equal D direct. And save it. All configuration S4 HANA cloud side finished, and you will be able to download the WSDL that contains the metadata to import into the S4 HANA cloud SOAP connector into the Mule application. Now we are considering creating data elements in SAP S4 HANA setup guide in BAPI custom object in prerequest in retail in cloud information model and in accelerators. Here you can see the object and how to create. Now we are considering connections in cloud connector reference, SAP S4 HANA cloud connector reference in Composer connector reference in Composer. connection display name here. The enter the connection display name. That will help you to remember the details of this connection. You can reuse the connection multiple times in the single flow in more in more than one flow, and the credentials are hidden after you create the connection. Therefore, it is helpful to provide a name that is easily identify this connection from others. Only you can see the connection. Other users in the Composer app must create their own connections. Now we are considering communication arrangement in SAP S/4HANA setup guide for sales rebate management in prerequest in manufacturing in accelerators. Here you can see the communication arrangement SAP _ com _ 0002 service name journey entry dash post synchronous and protocol SOAP. Now we are considering from studio in configuration in testing SAP in examples in unit. In the studio environment, add the SAP libraries to the class path, navigate to the build path, then configure build path, then in libraries tab, click add library button and select endpoint connectors dependencies and select the SAP connector option. This process is also described in the SAP connector documentation in the SAP documentation. You may also need to make java.library.path point to the folder where the navigation native libraries are located. The Immunity Studio plugin will try to find the these native libraries and configure them automatically when you try to run your test. In case they are not found, you need to add the following VM argument to the run configuration. In Studio top navigation bar, click run. Click the run configuration, then click the arguments tab. In the VM arguments dialog box, type the path of your libraries with the java.library.path argument. For example, the -d the java.library.path equal path /2/lib. Now we are considering SAP JCO SAP JCO extended properties in Mule runtime. You can configure any JCO any SAP connection properties to the SAP and then use them on the connector or endpoint. Some of these properties can be configured at the connector or at or endpoint level with the specified attribute mule dash config.xml file. The keys for these properties should be in the name same as JCO libraries expect, and so you can check the SAP client properties and SAP server properties. You can use these properties in the connector or endpoint by referencing the map with the attribute JCO client extended properties -ref. You can note important the values configured in this way should be passed directly to the JCO libraries without transformation. For example, Boolean values must be represented by the string 0 for false and 1 for true. The properties defined at the connector or endpoint level will override these values in the properties map. Also the properties configured at the endpoint will override the ones from the connector. As an example, we can as an exception example, we can consider this one, the timeout exception. This timeout exception happen inside the JCO library, SAP : timeout here. Here we can consider, as an error example, we can consider this one, missing JCO native library. Here you can see java.lang.exception initialize error. This is a JCO initialization fail with java.lang.unsatisfied link error colon no sap JCO in java library.path here, and you can see here the test failed, connection failed, error tying to test connection, report this incident, reason java.lang.exception initialize error, JCO initialization fail with java.lang.unsatisfied link error, no sap JCO 3 in java.library.path here. Now we are focusing on Oracle. Now we are focusing on Oracle. Oracle Corporation, formerly Software Development Laboratories, Relational Software Incorporation, and Oracle System Corporation, global corporation that develops and markets computer software applications for business. The company is best known for its Oracle database software, a relational database management system, and for computer systems and software such as Solaris and Java. Acquired in its purchase of Sun Microsystems in 2010, Oracle is based in Redwood Shores, California. Here you can see the integration architecture of the MuleSoft Oracle EBS connector. The Oracle EBS offers different technologies or products to address various types of integrations. The most widely used integrations for enterprise applications are data-centric integration. The next one is integration through web services using Oracle e-business suite. E-business suite integrated SOA gateway, ISG. Here you can see Oracle EBS 12.2 connector is inside Mule application. This Mule application is Mule application interacts with other external applications here, and Mule application interacts with Oracle here. And web service call is passed from Mule application to Oracle, and Oracle web service response is passed from Oracle to Mule application. Inside the database, PLSQL APIs, integration repository, and integration repository are inside Oracle, and database interacts with PLSQL API and integration repository here. And here you can see the Oracle e-business suite. Here that the Oracle e-business suite 12.2 connector Mule for the endpoint connector for Oracle e-business suite 12.2 EBS 12.2 connector facilitate connection between Mule runtime engine, Mule integration, and Oracle e-business suite 12.2 applications. Here you can see the connector architecture in Oracle EBS 12.1 connector. Oracle EBS offers different technologies or products to address various types of integrations. Most widely used techniques of integration with enterprise applications includes data-centric integration, event-driven integration using Oracle Business Event System, and XML gateway. And integration through web services using Oracle e-business suite integrated SOA gateway, ISG. Here you can see the Oracle business suite. Here the business event, XML gateway inbound, AQ queue tables, open interface tables, views, concurrent programs, PLSQL API, business events, XML and e-commerce gateway, and integration repository are in Oracle here. Here business events and XML gateway inbound are connected to AQQ tables. Here here you can see these things are in a separate box, and Oracle interacts with Oracle EBS connector, and here the Oracle is connected to Oracle EBS connector via receive messages, and here Oracle EBS connected to Oracle via database connection, and here the Oracle is Oracle EBS connected to Oracle via web service call, and Oracle is connected to Oracle EBS connector via web service response. Here XML gateway inbound queue consumer, business event topic consumer, and processes are in Oracle EBS connector, and Oracle EBS connector interacts with other external applications. Here you can see attributes and architecture in Oracle PeopleSoft connector Mule4. The component interface has the following 4 main attributes. Component interface name. Each component interface requires here the component interface. Component interface name. Each component interface requires a unique name. The programs calling a component use the name of the component interface to access the properties and methods. Keys. Get keys, create keys, find keys. Keys are special properties containing values that receive an instance get keys, so list the instance find keys of the component interface. You can add, remove, and change keys in PeopleSoft application designer. Keys are created automatically when you create the component interface. Get keys, the map to fields marked as search keys in the component search record. Create keys generated in CI when use tab on the component properties dialog allows the add action. Find keys map to fields marked as both alternate search keys and search key in the component search record. Properties and collections, field and records. Properties provide access to both component data and component interface settings. A property can correspond to a field or a scroll. Collection. Component interface collection is special type of property that correspond to the scroll containing fields and subordinate scrolls as defined in its underlying components. Type of properties. Standard properties are assigned automatically when a component interface is created. User-defined properties map to the record field on the PeopleSoft component that and are displayed in the PeopleSoft application designer. Methods. A method is a function that performs a specific task on a component interface at runtime. There are 2 main types of methods, standard and user-defined. Standard methods are those available all the component interfaces, and the following are the standard methods that a connector supports: create, cancel, find, get, save. User-defined methods are created in the PeopleSoft application designer to provide that functionality to component interface. Here you can see component search keys, component people code functions, and fields and scrolls are in the component. Here the keys keys are connected. Here the keys, methods, and properties and collections are inside component interface, and keys are connected to component search keys. Method are connected to people's code functions, and properties and collections are connected to field and scrolls, etc. Here the PeopleSoft application, you can see people code, and here the COM, VB, and COC++ in the external application here. Those are connected to component interface via API. Here you can see how to use a decision matrix in matrix to design integration patterns in Oracle ERP Cloud. The Oracle ERP Cloud is complete modern cloud ERP suite when advanced capabilities include analytics to react to market shift in real time and automatic updates to stay up to date in real time. It has following applications to solve a specific ERP needs within an application, an enterprise. One, Oracle Cloud Financials delivers decisive insights into a company's financial position and profitability with comprehensive global solution. Oracle Cloud Retail Solutions provide complete set of mission critical capabilities and cloud services and hardware. Oracle Enterprise Performance Management EPM enables modeling and planning across finance, HR, supply chain, and sales. Here you can see Oracle ERP Cloud Interact and other client and mobile and API databases and etc. And other things interacts with the Mule. Here you can see an example of Oracle ERP Cloud integration pattern decision matrix. Decision integration patterns present a conceptual, repeatable solution to common technology problems. Following architecture principles are recommended to build decision matrix during the architecture design process to support sustainable enterprise data integration architecture. One, the use study standard connectors to avoid custom development whenever possible. Always use MuleSoft out-of-box connectors where possible. Wherever possible, and avoid to use the custom code when connecting with various sources and target applications. Connectors always shield the business services from the technology and API changes from the third-party product. Event-driven architecture interacts with the event-driven interactions enable asynchronous communication and reduce the pollution overhead on source systems when there is a need to broadcast messages to multiple downstream apps. Follow API-led architecture. API-led connectivity provides the approach for connecting the exposing assets with this approach rather than connecting things point to point. Every asset becomes then a managed API. This image shows how to find the right decision pattern based on your needs. As an example, if you need to outbound data from cloud financials, and you have a large volume of data with complex data view transformations involved, you could choose BICC pattern as per matrix below. Here the bulk data and financial outputs, outbound and bulk data with complex transformations. Here you can see the process overview. Identify the cloud application. For example, financials and retail is connected to define connectivity type. For example, inbound and outbound. Then it's connected to find the volume and SLA details, and it's connected to identify decision criteria, and it's connected to make choice, and it connected to implement the solution. Here the decision analysis, decision to be made. I want to find right Oracle ERP cloud integration pattern based on my use case requirements. Here the financial outbound, financial inbound, financial outbound, retail app inbound, and retail apps outbound. Here the bulk data with complex transformations, bulk data and real time. Here the bulk data with complex transformation. If it is financial inbound, EBDI with parking lot database. If it is financial outbound, BICC, retail apps included. Then SFTP with parking lot database, and retail apps outbound, BDI. Here the bulk data. Then for financial inbound, FBDI, and financial outbound, BIP, and retail apps inbound, SFTP, and retail apps outbound, RIB. Real time Oracle Web Service, financial inbound Oracle Web Services, financial outbound on business events, retail apps inbound Oracle Web Services, and retail apps outbound, RIB. Here you can see business event design patterns in Oracle CFIN. Now that you are able to find which integration patterns to use based on the decision matrix previously mentioned, I will show I will show you how to implement the patterns with MuleSoft API-led architecture. Business events via Oracle Cloud Financials, CFIN outbound. Here ERP business events publish data that can be consumed by MuleSoft application and further processed to downstream applications. You can also enable pub sub patterns with anypoint MQ or similar message platform where there are multiple subscribers interested in the same data steps. Event is generated from the Oracle CFIN or Oracle Product Data Hub PDH. Review the list of business events supporting real-time integration was from PDH. MuleSoft received the event. Publish the event to any messaging system for interested subscribers to consume the process. Here you can see Oracle Cloud Financials CFN IN is connected to CFN events X API via business events. Here the CFN event API, event EXP API and MQ in MQE in experience here. So this is Oracle Financial Cloud Inbound Business Events here. And MQE is connected to MQQ1 and MQQ2 here. MQQ1 and MQQ2 and customer master PRC API, MDM customer PRC API are in process. Here MQQ1 is connected to customer master PRC API and Q2 is connected to MDM customer PRC API. Here the CDM rules sys API, finance DW sys API and finance MDM sys API are in system. Here the customer master PRC API is connected to CDM rules assist API and is connected to rules engine, and the customer master PRC API is connected to here finance DW sys API and is connected to DW, and here the MDM customer PRC API is connected to finance MDM sys API and is connected to MDM. Here you can see an example of FBDI integration pattern. File-based data import pattern with staging databases via Oracle. Via Oracle Cloud Financial CFIN inbound. This pattern recommends storing the data in an intermediate stage before processing it from the staging database to Oracle ERP cloud. This allows you to perform any complex transformations and validation rules against data. Additionally, you can take advantage of throttling the data from the source to the target in better way due to staging database. FBDI is one of the ways to integrate with Oracle ERP cloud. This pattern mainly used for loading bulk data into cloud ERP. File-based data import process involves generating FBDI file, uploading file to ERP, and then receiving callback from ERP service. This pattern can be used in any Oracle ERP cloud app, not just Oracle Finance Cloud. Steps process the input data message based on the order they come in. Each message will be parked in a storage for a few minutes parking time, so the system has chance to throttle the number of messages processed concurrently. A maximum number of the parallel process can be configured to throttle the outgoing calls. Generating file in FBDI format based on the data received from the source application. It gets triggered through the detection of trigger file or according to the integration schedule. Reading source file based on the trigger file name or integration schedule, transforming the source to FBDI. and staging FBDI file optional. Load the file generated from above in the Oracle ERP cloud. Once data is loaded, the Oracle ERP cloud asynchronously callbacks the Mule API with the result of the load and import process. Here you can see Oracle Finance Cloud inbound FBDI pattern with staging DB here. Here the enterprise scheduler is connected to Oracle FBDI PRC API, which is in the process, and here the Oracle FBDI PRC API is connected to staging DB syst API via control the message flow, generate message in FBDI format, achieve archived FBDI file, and its manifest the send and achieve the ERP cloud. Here the FTP files EXP API is connected to SFTP, and here the staging DB sys API is connected to staging database, and here the Oracle enterprise schedule is connected to Oracle FDB PRC API, and it's connected to Oracle FBDI sys API, and it's connected to Oracle Financial Cloud FCIN, and here the FCIN is connected to Oracle callback EXP API, and it's connected to Finance FTP sys API, and it's connected to SFTP, and here the SFTP files EXP API and Oracle fallback EXP API in experience layer, and staging DB sys and Oracle FBDI sys API and Finance FTP SFTP sys API in system. Here the example of Oracle ERP cloud services. This pattern recommends SOAP RESTful cloud services by leveraging Oracle standard web services available for CRUD create, read, update, delete operations. This pattern is applicable for both inbound and outbound steps. Step source application send the data to the Mule experience API endpoint. Oracle ERP Cloud exposes the web services to publish data, and these are available as business object. Payload received from the source is mapped to the format expected by the cloud business services. Operational steps. Data can be logged in a parking lot DB to maintain readability, traceability, and transaction history. And MuleSoft makes calls to underlying web services to publish data into Oracle ERP Cloud. And then the request is processed by the Oracle ERP Cloud, and the response is sent back. Response is returned to the send back, and here the response is returned to the source application, source system. Optional step: as part of post processing, the transaction log is updated in a parking lot database. And user is notified about the completion of the request with status. Here you can see web invoices EXP API, for example, in experience layer is connected to source web app, and also connected to Oracle ERP PRC API in process, and it's connected to Oracle ERP sys API in system, and it's connected to Oracle ERP Cloud apps via REST or SOAP. Here you can see Oracle e-business suite, and here the open interface tables, views, concurrent programs, PLSQL API, business event, XML, and e-commerce gateway and integration repository. These interacts with the Mule Oracle EBS connector, and it's intersect with the external applications. Here you can see use case XML in Oracle e-business suite 12.2 connector Mule 4. As an example too, we can consider add connector in Studio here in Oracle e-business suite 12.2 connector mule 4, and you can also add the connector using Exchange. Here we are considering add the connector in Studio. Step 1, in Studio create a Mule project. Step 2, in the Mule palette view, click X search in Exchange. And step 3, in Mule add modules to project, type EBS in the search field. Step 4, click the connector's name in available modules. Step 5, click add. Step 6, click finished. As an example 3, we can consider parameter connection. Connection types for this configuration here. Type PLSQL. This is in Oracle e-business suite 12.2 connector mule 4. Now we are considering, before you begin in Oracle EBS 12.1 connector, to use this information, you should familiar with Oracle EBS Mule runtime engine, Mule endpoint connectors, endpoint studio, Mule concepts elements in the Mule flow, and global elements. You need login credentials to test your connection to your target resource. To use this connector with Maven, view the pom.xml dependency information in the dependency templates in Anypoint Exchange. Here you can see the POM file information in Oracle EBS 12.1 connector. Replace the x.x.x with the version that corresponds to the connector you are using. Obtain the most up-to-date pom.xml file information. Access the connector Anypoint Exchange and click dependency snippets. Now we are considering add libraries for this connector to in web service endpoints in Oracle EBS 12.1 connector. To subscribe business events or to the XML gateway queue, the JMS configuration requires 2 external libraries. Go to the connector's JMS configuration. Click setup under the message setup drivers. Upload the selected upload and select your libraries. Oracle AQ API can be retrieved from the EBS instance at the $home/RBDMS/JLib/AQ Oracle JDBC driver can also be found in the instance at $oracle_home/JDBC/lib/OJBDC6.jar. Now we are considering add the connector to a studio project in Oracle EBS 12.1 connector. Add the connector using Exchange here. In Studio, create a Mule project. Click the Exchange icon in the upper left of the Studio taskbar. In the Exchange icon, click login and supply your Anypoint platform username and password. In the Exchange, search for EBS. Select connector and click add to project, and then follow the prompts to install the connector. Now we are considering log PSQL and web service request in responses. In Oracle EBS 12.1 connector, to log the PSQL and web service requests and responses when using connector, configure a logger. For PSQL request and response, to add this line to the loggers element in the log4j2.xml. For the web service requests and responses, add this line to the loggers element in log4j2.xml configuration for Mule app. Following example shows the loggers element. With the async logger, the configured to log the web service request and responses. Here you can, now we are considering use case call and login operation in Oracle EBS 12.1 connector. The sample flows calls an operation every 30 seconds and logs its output. One, drag your scheduler and then set the frequency to 30 seconds. Select Oracle EBS, then get party site from the Mule palette view and then drag it to the flow. Then configure its input and drag the logger and set its message to payload. In the use case XML, here is the code for aforementioned example here. Now we are considering JMS in connector configurations in Oracle EBS 12.1 connector reference. This parameter name, parameter here the name, type string, and this name, the name for this configuration, connectors reference the configuration with this name. Now we are considering, before you begin in Oracle PeopleSoft connector Mule4. To use this information, you should be familiar with the PeopleSoft Mule runtime engine, Mule, enter anypoint connectors, anypoint studio, and Mule concept elements in the Mule flow and global element. You need login credentials to test your connection to your target resource. Now we are considering POM file information in Oracle PeopleSoft connector Mule4. Replace x.x.x with version that correspond to the connector you are using. To obtain most up-to-date pom.xml file information, access the connector with anypoint exchange and click dependency snippets. Now we are considering what's new in this connector in Oracle PeopleSoft connector. The recognized user interface in connectors configuration. The input and output operations is JSON. Fixed date conversion is save operation. Now we are considering add the connector using exchange in add the connector to studio project in Oracle PeopleSoft connector Mule4. In the studio, create the MuleSoft project and click the exchange icon X in the upper left corner in the studio taskbar. In the exchange, click login and supply the endpoint platform username and password. Then in exchange, search the PeopleSoft, then select the connector and add to the project and follow the prompts to install the connector. Now we are considering log request and responses in Oracle PeopleSoft connector Mule4. To log request and responses using responses when logging the connector, configure a logger by adding this line to the loggers element in the log4j2.xml configuration file for MuleLab. Following example shows the loggers element with the async logger line added. You can view the app log as follows. If you are running the app from the anypoint platform, output is visible in the anypoint studio console window. If you are running the app using the Mule from the command line, the app log is visible in your OS console. Unless the log file path is customized in the app log file, log4j2.xml, you can view the app log in this default location mule_home/logs/appname.log. For information about the app, see the configuring logging in the documentation. Now we are considering use case retrieving a collection of employee records in Oracle PeopleSoft connector Mule4. Create a new Mule project in the Anypoint Studio. Drag the HTTP listener to the canvas and configure the following parameters: display name, extension configuration path. Drag the PeopleSoft invoke operation next to the HTTP endpoint component and configure it according to the steps below. Add the new PeopleSoft configuration by clicking the plus sign in the basic settings field. Configure the global element completing required fields with your credentials. Add the PSGOA library. Add the CI personal data to the component interface IDs. Click the test connection to confirm the Mule can connect the PeopleSoft instance, and then if the configuration is successful, click OK to save configuration. Otherwise, reviewer correct the incorrect parameters and then test again. Back to the parameters properties editor. If of invoke operation, configure the remaining parameters: display name, extension configuration, component name, operation. The connector settings, then add the transform message co-element between HTTP endpoint and the PeopleSoft endpoint to provide the input parameters required by the find method, and the fields should be automatically populated. Inside, add the transform message after PeopleSoft element to display the response in the browser. Add the logger scope after the JSON transformer to print the data is being passed to the PeopleSoft connector in the MuleSoft console. Save and run the Mule application, then open a web browser and check the response after entering URL http:// localhost 8081 find $ID equals 0004 and ampersand name equal ampersand last name and etc. And if there are records in your MuleSoft database whose key prop underscore EMPL ID contains the value mule, you should get a JSON collection with these records. Otherwise, you receive the empty collection. In this example, input parameters of find operations are optional. Now we are considering default configuration in Oracle PeopleSoft connector refers Mule4. Here the field name, the name for this configuration connectors reference to the reference the configuration with this name. Now we are considering before you begin in Oracle Siebel connector 4.0. To use this information, you should familiar with Oracle Siebel Mule runtime engine, Mule anypoint connectors, anypoint studio, Mule concepts, elements in the Mule flow, and global elements. You need to log in credentials to test your connection to your target resource. To use this connector Maven and we view the pom.xml dependency information in the dependency snippets in the anypoint exchange. Because of how closely the connection is coupled with Siebel CRM, you should have a working knowledge of Siebel business component, business object, business services, and integration object. Siebel connector requires the following two Siebel jar files: siebel.jar and siebel ji_xxx. Choose the Siebel ji_xxx.jar based on the local of the Siebel installation. For instance, the local Siebel installation in US_en use the Siebel ji_enu.jar and Siebel.jar and Siebel ji_enu.jar are available in the Siebel home for /8.1.1.11 tools_1 /classes folder in the Siebel server. Siebel home is the installation directory of Siebel. The connector is now conglomerate with the previous three modules: Oracle Siebel business project objects, Oracle integration objects, and Oracle Siebel business services. Now here you can see the POM file information in Oracle Siebel connector 4.0 Mule4. Replace the XYZ with the version that correspond to the connector you are using. To obtain the most up-to-date pom.xml file information, access the connector in anypoint exchange and click the dependency snippets. Here you can see the connector in Design Center in Oracle Siebel connector 4.0 Mule4. In Design Center, click setup, then upload, browse for select the driver for this connector on your file system and upload it. Alternative search for and select the driver is already uploaded. Click the trigger. You can create global element by selecting this connector as the trigger. If the global element is not needed, you can use the HTTP listener or schedule trigger. To create the optional global element for connector, set these fields here. Name, enter the name for the configuration to reference it later, or user. Enter the Siebel username to be used. Password, enter the password corresponding Siebel password. Server, enter the server IP address of your Siebel instance. Port, enter the port number, default value 2321. Server name, enter the Siebel enterprise server name, and RSA encryption. Choose if you want to use RSA encryption. Default value is false. Object manager, enter the value of the object manager of your Siebel instance. Language, enter the corresponding to the local Siebel instance. Default value is ENU. Encoding, you enter echo encoding type supported by Siebel server. The default value is UTF-8. Select the plus sign to add the component. Select the connector as a component and configure these fields. Select the connector configuration that previously connected, and fill the fields of the operation that you are using accordingly. Now we are considering add the connector using the in the Exchange. Add the connector into a Studio project in Oracle Siebel Connector 4.0. In the Studio, create a Mule project. Click the Exchange icon next in the upper left corner of the Studio taskbar. In Exchange, click Login. Supply your endpoint platform username. In Exchange, search for Siebel. Select the connector and click Add to Project. Follow the prompt to install the connector. Here you can see logged requests and responses. In Oracle Siebel Connector 4.0 Mule 4 to log requests and responses when you are using connector. Configure the logger by adding the line to the loggers element in the log4j2.xml configuration file for the Mule app. Following example shows loggers element with the async logger line added. You can view the app log as follows. If you are running the app log app from the endpoint platform, output is visible in the endpoint studio console window. If you are running the app using the Mule from the command line, the app log is visible in your OS console. Unless the log file path is customized in the app's log file log4j2xml, you can also view the app log in the default location mule_home/log/appname.log. For more information about the app log, see the configuration logging in the documentation. Here you can see a use case in Studio. The use case in Studio. Example use cases in Studio in Oracle Siebel Connector 4.0 Mule 4. The following common use cases for the Siebel version 4.0.0 connector. Create a business component, action, account, etc. Create a new Mule project in Endpoint Studio. Add a suitable Mule inbound endpoint, such as HTTP listener. To begin the flow, drag create business component operation from the Siebel JDB palette into the canvas and select that select it to open the properties editor. Configure the operations parameters. Drag the transform message connector between HTTP listener and the Siebel connector on the flow. Configure the input payload with the desired fields. To the execute the business service, create contract, create account. Add the new Mule project in the Endpoint Studio. Add a suitable Mule inbound endpoint such as HTTP listener to begin the flow, and drag the execute a business business operation from the Siebel JDB palette into the canvas and select it to open the properties editor. Configure the operations parameters. Drag the transform message connector to the HTTP listener and the Siebel connector in the flow. Configure the input payload with the desired field. Execute Siebel adapter. Create a new Mule project in creating an integration object. Create a new Mule project in the endpoint studio. Add a suitable Mule inbound endpoint such as HTTP listener to begin the flow. Drag the create business component operation component from the Siebel JDB palette into the canvas and then select it to open the property editor. Configure the operations parameters. Drag the transform message connector between HTTP listener and the Siebel connector in the flow. Configure the input payload with the desired field. Here you can see use case XML in Oracle Siebel connector 4.0 Mule4 in Mule4. HTML extract from the project been using the Siebel connector here. Now we are considering Siebel in configurations in Oracle Siebel Connector 4.0 reference Mule4. The parameter the name for the configuration, connectors reference the configuration with this name. Now we are considering create a secure Oracle connection in configure an Oracle TLS database connection in Oracle Connector. The following example shows how to configure a secure Oracle connection in Endpoint Studio. In Studio, navigate to the global element view, click create to open the choose global type view. In the filter field, type database, select database config and click OK. In the database config window, the connection field, select Oracle connection. To configure, click the configure to add the Oracle JDBC driver and select either use local file, install the library using local file and add the Maven dependency, install the Maven dependency to add the project. 6. Set host to localhost, port to 1522, user to system, password to Oracle, and the instance / service name to exe. Click TLS. In the true store configuration section, set the following field: path, some path / client truststore.jks, password, some password, and type jks. In the keys store configuration section, set the following field: path, some path / client store.jks, password, some password, key password, some password. Due to Java Secure Socket extension JSSC, you must set the password and key password field with the same password value for the key store configuration. Type jks. 10. Click the test connection to confirm that the Mule can connect to the database. Click OK. The following screenshot shows the secure Oracle connection general and TLS configuration window in Studio. Here you can see trust store configuration section in the and the fields here, and here you can see here the path, password, key password, path, password, and type. And here you can see key store configuration section. Here the path, password, password, key password, type. In the configuration XML editor, TLS colon context configuration look like this here. As an exception example, we can consider this occurred in Oracle EBS connector. Here you can see the links href equal https etc, and This is D2RLVS 3D900 .NET//3_images/12424/EBS_connector_0.1.png and etc. And you can see here java.language reflect.undeclared throwable exception at com.sound.proxy and etc. And here at org.mule.modules.oracle.connection manage multi-strategy.test connectivity etc. And we are focusing on IBM in full International Business Machines Corporation, leading American computer manufacturer with a major share of the market both in United States and abroad. Here you can see IBM integration with MuleSoft. Client summary. In this example, client is based on the Richmond, Virginia, involved in a full service freight transformation, has 160,000 employees, 30 trailers. Their annual turnover is 5 billion US dollars and employees over 100 people. Executive summary. This project is to streamline multi-technology integration process and track the audit of data transfer. Problem statement. The IBM applications are integrated with the third-party applications. Those applications are rapidly integrated without these standards. Solution. The higher level infrastructure for IBM Mule interface consists of 3 parts. IBM application trigger event, business flow represent the IBM application would trigger the event to transform data through Mule into third-party applications. In transaction interface, the interface with Mule would be at the transaction level with control data indicating the type of transaction. Data queues indexed by the transaction number would act as a trigger to indicate transaction is available for pickup or delivery. Customized staging tables would store the data for each transaction type for Mule to transfer. Mule will act as a carrier to pick up transactions, send the data, receive the response, and relay back the information to the triggering application. Business benefits. No business rules would be present in the Mule layer. The rules will be handled in the triggering and the receiving applications. Sequential transaction number would be the key for all 3 systems involved. Enables the same business logic to be re-triggered if required. Intermediate staging tables and data queues will be used for Mule to refer to, thus not impacting the master database and speeding up the time taken for transaction to be completed. Here you can see a ERP and web transaction framework and interface programs in AS400. Here the ERP, order entry, POS, inventory, merchandising, etc. Here the ERP interact with interface program. Interface program interacts with create transaction, CT, CRT, TRN process and request and response staging. Here create transaction is connected to web control table, ESB types, transaction history, ESB HDR, and transaction errors, ESB log. And here create transaction interact with data, queue adapter. Data queue adapter interact with data queue JMS bridge here, and here the request DQ is connected to AS400 connect, or response DQ. AS400 connect is connected to response DQ, and the data queue JMS bridge is connected to flows here, and here the request and response staging interacts with the database connector. Here the database connector is inside flows, and flows inside Mule, and here Mule interacts with third-party applications. Here you can see the detailed steps and areas of responsibility for Mule and IBM I sites in IBM I Business Logic API with Mule. Here the solution design. A high-level design includes the MuleSoft API that invoke IBM I Business Logic programs and execute the request and response data via web transaction framework WebTF. And staging DB for iTables. The flow diagram here explains the detailed steps and areas of responsibility for Mule and IBM I sites. Finally, let's go include with regarding the coding. You will see the building up an API that execute IBM Business Logic is pretty straightforward and includes straightforward. In the Mule create RAML API definition in API design or AnyPoint Studio. Then the Mule generate implementation stuff for RAML in AnyPoint Studio. In IBM I define new web transaction type and interface program. For the IBM I optionally create staging tables for request and response. Mule call WebTF store procedure CTTRN to create new transaction. Optionally insert request data into DB staging tables. Mule optionally call WebTF store procedure PRCTRN to process transaction. Mule optionally retrieve response data from DB staging tables. Mule transform the response data into API response format. Here you can see a Mule and AS400. Here the application event is connected to create transaction. Create transaction is connected to build request. Here the create transaction interacts with CRTTRN via DB2 stored procedure called CRTTRN, and CRTTRN is connected to staging here. And here you can see transaction ID via transaction ID, and staging here TRN HDR, TRN log. And here the create transaction is connected to build request stage STG, and it's connected to the staging here. And build request STG is connected to process transaction. It interacts with the PRC TRN, and it's interact with the business logic gateway, and it's interact with the business logic, and business logic is connected to staging here, and staging is connected to here the return code equal 0 equal OK, and it's here the staging is connected to get response, and here the process transaction is connected to get response, and get response is going to continue with app flow. Here the application event, create transaction, build, request, STG, process transaction, get response, and continue with app flow in Mule. And here the CRTTRN, staging, PRCTRN in web transaction framework. And here the business logic gateway is in the interface, and business logic is in the application. Here the web transaction framework, interface, and applications are in AS400. As an example, we can consider this one to publish messages. Here, sending a message to a queue. Here the IBM MQ connector Mule 4. The IBM MQ connector version 1.6 Mule 4 endpoint connector for IBM MQ. IBM MQ connector enables an app to do messaging to a IBM MQ broker using IBM MQ JMS implementation. The main features include pub sub pattern support for any given destination, listen reply pattern support for any given destination, publish consume pattern support for any given destination with fixed or temporary reply queue, non-blocking publishing and consumption messages. Here, when used in its default form, the connector will publish whichever is in the payload. But what happens if the payload is not in the correct format and you need to make a transformation? You could place a data wave transformation before publish operation, but that would cause the message payload to change and impact the operation placed after publish operation. To avoid this undesired impact, you can now place the transformation inside publish operation. Now the transformation can be used for generating the content that will be published without producing a side effect on the message in transit. This is as an example too, we can consider related to publish messages, publishing a message to a topic. This is a IBM MQ connector Mule 4, IBM MQ connector version 1.6 Mule 4, endpoint connector to IBM MQ. IBM MQ connector enables an app to do messaging to an IBM MQ broker using IBM MQ JMS implementation. The main features include pub sub pattern support on the given destination, listen reply pattern support for any given destination, pub consume pattern support for any given destination with fixed and temporary reply queue. Non-blocking publishing and consumption of messages. The publish operation can also be used to publish message to a given topic destination. All configurations of the operation and message are identical, but the destination type here, destination type parameter has to be declared as a topic destination. For the same example seen before, if instead of sending the message to the queue, we want to publish it to the topic, and here we will do here. As an example 3, we are considering connection modes. Here we are considering client connection configuration on XML. This other mod is binding connection mod. Here the IBM MQ connector version 1.6 Mule 4. The client connection mod lets you to connect to the IBM MQQ manager running on this in the same system that is being run in the Mule application or in other system. In both cases, IBM MQ connector will connect to the IBM MQQ manager over TCP/IP. For this connection mode are available for the following configurations. Host, this is a required parameter. The host containing the IBM MQ broker. The port default value is 1414. The queue manager listener port. Queue manager. The queue manager used when selecting a channel definition. Channel, name of the channel to connect to, dev.admin.svrcon. Connection name list, host to which the client attempts to reconnect after its configuration is broken. The connection name list is a comma separated list of host and IP pairs. Here you can see the client connection configuration on XML here. Here we are considering add the connector in Studio. Here we are adding IBM CICS transaction gateway connector, Mule 4. IBM CICS transaction gateway connector version 2.3. Anypoint connector for IBM CICS transaction gateway, IBM CTG connector provides integration with backend CICS apps using CICS transaction gateway. For Java platforms, CTG implementations implements the Java cryptography architecture, JCA resource adapter to connect Java applications to the customer information control system, CICS system. The connector serves as a link between Mule apps and the IBM CTG. Here, step 1 in Studio, create a Mule project. Step 2, in the Mule palette view, click search in Exchange. Step 3, in add modules to project, type CTG in search field. Step 4, click this connector's name in available modules. Step 5, click add. Step 6, click finish. Now we are considering before you begin in IBM CICS transaction gateway connector Mule 4. To use this information, you must be familiar with IBM CTG, Mule Runtime Engine, Mule Anypoint Connectors, Anypoint Studio, Mule Concept, elements in a Mule flow, and global element. You need login credentials to test your connection to your target resource. To use this connector with Apache Maven, view the pom.xml file, dependency information from dependency snippets via link in the Anypoint Exchange in the documentation. Here now we are considering CICS customer information control system in terminology in IBM CICS transaction gateway connector Mule 4. Set of enterprise application service with the support for high transaction workloads in a secure, scalable, cost-efficient environment. CICS applications are written in a variety of languages from Java to COBOL. Now we are considering adding a connector using Exchange add the connector to the Studio project in IBM CICS transaction gateway connector. In the Studio, create a Mule project. Click the Exchange icon X in the upper left of the Studio taskbar. In the Exchange, click the login and supply your Anypoint platform username and password. In Exchange, search for CTG, select connector and click add to project, and then follow the prompt to install the connector. Now we are considering configure a Studio project in IBM CICS transaction gateway connector Mule 4. Drag the connected operation to the Studio canvas. Configure the global element for the connector. Here there are fields required libraries. Here the CTG server.jar, CTG server library and CICS.jee.jar, CICS.jee, and CCF2.jar, CICS common connector framework, CTG client.jar, CTG client library, and Geronimo J2E connector 1.6 spec.jar. Notes: use the jar files that come bundled with the installation of the CTG server instead of downloading the SDK zip from the IBM's website to ensure the compatibility between the connector and the CTG system. Here the host, enter the host name of the CICS-TG and port. Enter the port on which the CICS-TG is running. Default value is 2006. Server name, enter the CICS user ID, optional if the security is not enabled in the CICS. Enter the name of the target CICS server as defined in the CICS TG configuration file, is optional. Username, enter the CICS user ID, optional if the security is not enabled in the CICS region. Password, enter the password for CICS user ID, optional if the security is not enabled in the CICS region. Hit 3. Add the dependencies, select add dependency and complete the fields. Go to the additional settings and complete the configuration. There are here the here the key store location. Enter the location of the key stores containing the certificates required for the SSL client, optional, and key store password, and enter the password required to access the key store for an SSL client, optional. Connection timeout, enter the socket timeout for the client to CTG. Default value is 0, not timeout, no timeout. CTG trace, if set to true, enable all debug level CTG tracing. Default value is false. Response timeout is overridden by the ECI timeout parameter if configured on the server side. Choose the operation. IBM CTG connector supports the following two outbound operations. Execute invoke CICS program with the data encapsulated as channels and containers. Execute using Comaria. Invoke the CICS program with the data encapsulated as a Comaria. Requests are limited to maximum 32 KB. You can see POM file information in IBM CICS transaction gateway connector MuleSoft. Replace x.x.x with the version that corresponds to the connector you are using. To update the most up-to-date POM.xml file information, access the connector in the Anypoint Exchange and click dependency snippets. Now we are considering enable login for request and responses in IBM CICS transaction gateway connector MuleSoft. To enable logging of the interactions of the connector with IBM CTG, a logger must be configured in the log4j2.xml file of the Mule app as follows here. Put the async logger statement in the loggers block in the log4j2.xml file. Now we are considering common use cases in IBM CICS transaction gateway connector MuleSoft. Invoke a Comaria program, invoke a channel program, invoke a Comaria or channel program inside the transaction scope, add the custom metadata. Note: to successfully run the first three use cases, the target CICS system must have the specific programs. Now we are considering IBM create a configuration file for a connection in configure a connection in IBM CTG connector 2.3 examples in Mule4. Create a configuration file that includes the properties for a connection. Create a file name mule-app.properties in the /source/main/resources/folder source/resources folder. In the mule-app.properties file, create a set of properties for the connection similar to the ones that follow, replacing the bracketed text, including the brackets with the correct values for your configuration. This may vary depending on the selected connection configuration. For more information of creating a properties file, refer the configuring property placeholders in the documentation. Here you can see the ibm.host, hostname, ibm.port equal port number, etc. Now we are considering parameters in configurations in IBM CTG connector reference Mule4. Here the name, parameter name, the name for the configuration, for this configuration, connectors reference the configuration with this name. Now we are considering client connection mode in IBM MQ connector. The client connection mode lets you to connect to IBM MQ queue manager running in the same system as that is being run the Mule application or in other system. In both cases, IBM MQ connector will connect to the IBM MQ queue manager over TCP/IP. For this connection, the connection mode are available following configurations. The host required host contained in the IBM MQ broker, parameter port and not required, and default value is 1414. The queue manager listener port, parameter queue manager not required. The queue manager used when selecting a channel definition. Parameter channel not required. Name of the channel to connect to. Parameter connection name list. Not required, and host to which the client attempts to reconnect after the connection is broken. The connection name list is the separated list of host and IP ports. For example, 0.0.0.0.0 within bracket 1414, some host .domain.com within bracket 1415. The client connection configuration on studio here. Here the client connection configuration on XML. Now we are considering define global defaults. In IBM MQ connector Mule4, the IBM MQ config allows you to define multiple parameters to use as a default while consuming or publishing messages. This way you can define a global default behavior for all the operations associated with the config and override each parameter only when the operations that require custom behavior. For example, we can define the default selector behavior when consuming a message in any of the operations that are associated with this config, and also a default. In this case, every consume or a listener operation associated with this configuration uses the selector by default, while every time a publish or consume occurs, the outgoing message has a TTL of 60 seconds. All of these properties can be overridden at the operational level when required. To publish the message with the shorter TTL, use this example configuration that overrides the parameter. Now we are considering select a JMS spec in IBM MQ connector Mule4. The main command parameter is a JMS specification used to select between all supported specifications, which are 2.0 and 1.1. This specification must be supported by the broker implementation associated to this connection, otherwise the connection fails. Warning: features available only in JMS 2.0 won't work with any other specification. Now we are considering provide credentials for authentication. To establish the authenticated connection, you need to configure the username and password in the element. Now we are considering set up the connection required libraries. IBM MQ external libraries. To use the IBM MQ connector, configure the external IBM MQ library. The IBM MQ client library must provide com.ibm.mq.jms.mq connection factory implementation. Tip here, use the IBM MQ all client library. For example, you can use this one. Now we are considering parameters in configurations in IBM MQ connector reference Mule4. Here the parameter name, the name for this configuration, connectors reference the configuration with this name. Now we are considering add a namespace for the connector in IBM MQ Connect XML and Maven support Mule4. This example shows how the namespace statements are placed in the Mule XML block here. Here you can see a manual acknowledgement in handling message acknowledgement in IBM MQ Connect example in Mule4. As you may expect, the manual ACMOD here, the manual ACMOD delegates all the responsibility of the performing ACK on the message to the application logic. With this configuration, every message received by either in the listener or consume operations as a ACK ID available in the Mule message attributes, which identify the message uniquely for a given connection. here the with this configuration, every message received by either listener or consume operation has an ACK ID available in the Mule message attributes, which identify this message uniquely for a given connection. ACK ID that identify the message passes the IBM MQ :ACK operation. Do message processing. Now we are considering increasing concurrent message processing in IBM MQ tuning for performance. A good way to improve the performance of your application is to increase the number of concurrent consumers that receive messages from the same destination. This can be done easily in IBM MQ connector by configuring number of consumers parameters. Out of the box, the listener uses 4 consumers concurrently at the same destination, but you can increase this number to a value that better fits your needs. Increasing the number of consumers is the easiest way to improve the throughput of your listeners' destination. Now we are considering enable verbose logging in troubleshooting IBM MQ connector Mule 4. Sometimes you are not sure why your application is failing, and you require a better understanding of what's going on in the app's interaction with the MQ server. To gather detail logs, use the configuration file to increase the logging level on the server side, and also enable verbose logging for JMS connector and MQ packages. Access the Anypoint Studio and navigate to the Package Explorer view. Open your application's project name. Open the source main resources path folder. Open the log4j2xml file inside your folder. And in the following line is already in the log4j2 XML file. Uncomment it to enable it, otherwise add it. As an exception example, we can consider this one: fail to deploy. This is occurred in IBM CTG connector. Fail to deploy artifact IBM CTG connector. See below, and org.mule.runtime module.license.api.exception.invalid license exception. Runtime license does not contain entitlement IBM CTG connector required by plugin IBM CTG. Now we are focusing on custom apps. You can add your custom Mule module to your Mule projects in Anypoint Studio. As an example, we can consider this code segment, this segment here. In your Anypoint Studio project, edit the pom.xml file with the group ID, artifact ID, with the group ID, artifact ID, and version of your Mule module. This information is available in your Mule's pom.xml file, for example. It is also reflected in the folder structure in which the Mule module was installed. $maven _rep_home /group ID _path and artifact /artifact ID /version. As an example too, we can consider adding custom modules to a project. You can add your custom Mule module to your Mule projects in Anypoint Studio. These instructions assume that you coded your Mule module using the Mule SDK and that you followed the proper setup steps. Mule modules are developed by as Maven projects. Therefore, your custom Mule module must be installed in a local or online Maven repository. Here in step 1, in your Anypoint Studio project, edit the pom.xml file with the group ID, artifact ID, and version of your Mule module. And step 2, save your changes to your studio project's pom.xml file. After Anypoint Studio downloads the new dependency, you will see your new Mule module in the Studio palette. Now we are focusing on database. Database, also called electronic database, any collection of data or information that is specially organized for rapid search and retrieval by a computer. Databases are structured to facilitate the storage, retrieval, modification, and deletion of data in conjunction with various data processing operations. A database management system, DBMS, extract information from the database in response to queries. As an example, we can consider this segment. In the configuration XML editor, the db:select configuration looks like this. Here the database connector 1.13 Mule4 Anypoint connector for database connector establishes communication between your Mule app and a relational database. Database connector can connect to almost any Java database connectivity, JDBC, relational database, and run SQL operations. An application can support multi-tenant scenarios using the same configuration element, changing the connection attributes based on, for example, information coming from each request. To add and configure the select operation in Studio, follow these steps. This is under database connector 1.13 Mule4. Step 1, in the Mule palette view, search for the database and select operation. Step 2, drag the select operation into Studio's canvas. Step 3, in the general tab of the operation configuration screen, click the plus sign next to the connector configuration field to access the global element configuration fields. Step 4, specify the database connection information and click OK. Step 5, set the SQL query text field to the SQL query to execute. For example, select asterisk from planet where name equal :name. Here you can see the step 5, set the SQL query text field to execute to the SQL query to execute. For example, select asterisk from planet where name equal :name. As an example 3, we can consider this. When you configure a database connection, Anypoint connector for database connector can connect to any database for which JDBC driver is available. Here configuring data source reference connection. The database connector generate a JDBC's data source by using the parameter values you provide when you configure the generic connection field. If you want to create your own data source and use it to connect a database, configure the data source reference connection field. So this example shows how to use Anypoint Studio to configure a data source reference connection to a Derby database. Here, step 1 in Studio, in the source src/main/resources folder, create a data source config.xml bin file to define a custom NHydra data source that connects to a Derby database. Step 2, return to your MuleSoft. Go to the global element view and click create to open the choose global type window. Step 3, in the filter field, type Spring, select Spring config and click OK. Step 4, in the Spring config window files field, add data source dash config.xml to reference the Spring configuration file with the Spring module. Step 5, click OK. Step 6, in the global elements view, click create to open the choose global type window. Step 7, in the filter field, type database, select database config and click OK. In step 8, in the database config window, for the connection field, select data source reference connection. Step 9, click config to add the required JDBC driver and select either use local file, install the library using local file, add Maven dependency, install a Maven dependency to add to the project. Step 10, for data source ref, add the bin id JDBC data source created in the data source dash config.xml bin file. Step 11, click test connection to confirm that Mule can connect to the database. Step 12, click OK. Here the step 1 in Studio, in the source src/main/resources folder, create a data source dash config .xml bin file to define a custom NHydra data source that connect to a Derby database. Here you can see data source dash config.xml file contents. Here in step 5, click OK. This is a Spring configuration data source. Here the step 12, click OK. This following screenshot shows the configuration. This is the data source reference connection. And here you can see in the XML editor, both Spring and database configurations look like this. Here you are considering common use cases for the connector in database connector 1.14 MuleSoft. Database connector enables you to perform predefined queries, dynamically constructed queries, and template queries that are self-sufficient and customizable. Specify data view expressions in connectors field and configure attributes dynamically depending on the database configuration you use. Use a source listener operation to read from the database in the source data source section of the flow. Execute other operations to read and write to a database anywhere in the process section. Perform multiple SQL requests in a single bulk update. Make data definition language DDL requests that alter the data structure rather than data itself. Execute stored procedures and SQL scripts. Now we are considering configure a global element for the connector in using AnyPoint Studio to configure global configure the database connector 1.14 MuleSoft, database connector 1.14 MuleSoft. When you configure a connector, it's best to configure a global element that all instances of that connector in the app can use. Database connector can connect to any database for which the JDBC driver is available. to make it easier to connect to the most popular databases such as MySQL, Oracle, and Microsoft SQL Server. The connector includes series of different connection types. To configure the global element for database connector, follow these steps. Select the operation in the Studio canvas. In the configuration screen for the operation, click the plus sign next to the connector configuration field to add the global configuration fields. In the database config window, for the connection, select any of the connection types to provide to this connection. Data source reference connection, Derby connection, generic connection, Microsoft SQL Server connection, MySQL connection, Oracle connection. On the general tab, specify the database connection information for the connector. On the transaction tab, optionally specify the transaction isolation or OXA transaction when connecting to the database. On the advanced tab, optionally specify the connection pooling and connection information including the reconnection strategy. Click test connection to confirm that Mule can connect with the specified database and click OK. The following screenshot shows the database connector global element configuration. The database connector here, the global element configuration here. Now we are considering a data source reference connection in connection times in configurations in database connector reference 1.14 mule flow in database connector 1.14 mule flow. The parameter pooling profile provides a way to configure database connection pooling. The type is pooling profile. Now we are considering configure data source reference connection in configure database connection in database connector 1.40 mule4 database connect examples mule4 here. Database connector generates JDBC data source by using parameter values to provide when you configure generic connection field. If you want to create your own data source, use it to connect to a database, configure data source reference connection field. Following examples shows how to use Anypoint Studio to configure data source reference connection to a Derby connection database. Here in Studio, in the source main resources folder, create data source config.xml bean file to define custom NHydra data source that connects to a Derby database. Here the data source config.xml file. To return your Mule flow to the global element view and click create to open. Choose global type window. In the filter type field, type Spring, select Spring config and click OK. In the Spring config Windows files field, add data source -config.xml to reference the Spring configuration file with the Spring module. Click OK. The following the global elements view, click create to open, choose global type window. In the filter field, type database and select database config and click OK. 8 in the database config window, for the connection field, select data source reference connection. 9 click configure to add required JDBC driver and select either use local file, install the library using the local file, add my1 dependency to install the my1 dependency to add the project. For data source ref, add the bean ID, the JDBC data source created in the data source -config.xml bean file, and 11 here click the test connection to confirm that Mule can connect to the database and click OK. In the XML editor, both Spring and database configurations look like this here. Now we are considering enable verbose logging in troubleshooting database connector Mule4 in database connector 1.14 Mule4 to get a better understanding of why an application interaction with the database is failing. Temporarily enable verbose logging for database connector. Choose one of two options to enable verbose logging. Manually change the log4j2.xml file or via anypoint runtime manage if you are using Cloud Hub APIs. Remember to always disable the enhanced verbosity after troubleshooting because it affects your Mule application performance. To enable verbose logging in the configuration, access the Anypoint Studio and navigate to the Package Explorer view. Open new application project's name, open source main resources path folder, open log4j2x.xml file inside the folder, add the async logger tag inside logger tag. Here. Save your application changes. Click the project name in the package explorer and click run, then run as Mule application. Now we are considering add the namespace for the connector in database connector XML and Maven support Mule4 and database connector 1.14 Mule4. This example shows how the namespace statement are placed in the Mule XML blocks. Here you can see input parameters in migrating parameterize queries in migrate database connector, in migrate connectors in Mule migration to Mule4, in Mule4 for Mule3 users in Mule runtime. Both Mule3 and Mule4 input parameters are supplied as the key value pairs. Those keys are used with the semicolon character to reference to a parameter value by name. This means the written in the SQL parameters queries. Mule3 doesn't need changes to be used in Mule4. This approach is recommended to avoid SQL injection attacks, and it allows connector to perform optimization that improve overall performance of the Mule app. Input parameters in Mule3, each input parameter was defined as a db colon in Mule3, each parameter has defined a db colon in param element inside the db colon select operation, which had a name attribute for the parameter name and the value attribute which holds the parameter value. In Mule4, input parameters are defined as a map, db input parameters, where the key is the name of the parameter and the value as the parameter value. This map can only be created using data view. Here the Mule3 example parameterized select query. Here the Mule4 example parameterized select query. Now we are considering define the munit db server in configuring database server utility in an munit test in munit examples in munit. Define the database server by using the munit db server config from the global element in your canvas. For this example, define the DB structure and convert content using CSV file. Go to the source test resources directory in a project. Create a file name job title lookup.csv containing the following values here. Navigate to the global elements tab and select munit db server config element. Click edit and complete the field. Munit db server config job title lookup.csv and munit db server config database name and munit db server config mod equal MySQL. Here CSV title job title lookup, and here mod equal MySQL. Define DB configuration to connect to a DB server. And define db.properties file in your source test resources folder that will pick up your test database configuration. Now we are considering add the database connect configuration in connecting to a database from app in integration American flight process example, in developing American flight app example in Anypoint Code Builder tutorials. In the Anypoint Code Builder, open American WS Anypoint Builder.xml. In the configuration XML, add the global db config global DB config snippet about the flow element. Insert the snippet XML by pressing Ctrl plus spacebar in Mac or Command plus spacebar in Windows. Typing MySQL to search for snippet and selecting the snippet db :mysql -config. Snippet XML about the flow element here. Edit the attributes in db config to produce XML configuration. Review the complete configuration XML. Proceed to write a query to return all flights. Now we are considering internal handler configuration in MySQL example configuration in send an event data from runtime manager to an external database, in export data to external analytics tools, in troubleshooting in runtime manager. Download the MySQL JDBC driver from http://div.mysql.com /download/connector/j/ extract the zip file. Copy the MySQL connector Java version.jar file to Mule home /plugin Mule agent plugin lib modules. Modify the file mule _home config mule agent.yml to include the following here. Now you are considering a validate that in the in a MuleDB server processes in database in MUnit processors, utilities and MUnit processors in MUnit. The MUnit DB server allows you to validate that the result of the queries are as expected. To do this, you can use the validate that operation. Set the result property to CSV. With rows separated by new line \n as shown here. An exception example, we can consider this one, java.sql exception cannot get connection for URL jdbc SQL server /10.11.12.13.1433 database name equal some db and user, some user password, some password. The TCP/IP connection to the host 10.11.12.13 port 1433 has failed. Error connect timeout. Verify the connection properties. Make sure that the instance of SQL server is running on the host and accepting TCP/IP connections at the port. Make sure the TCP/IP connections to the port are not blocked by a firewall. org.mule.db.internal.domain.connection creation exception. Message payload is of type string. As an error example, we can consider this error org.mule.retry.notification.connection notifier failed to connect /reconnect /jdbc connector. Here you can see the name jdbc connector, lifecycle initialize this and number of current transaction receivers for etc. Connected false. And root exception was cannot get connection for URL jdbc postgres SQL /xxx etc. Now we are focusing on JMS, the Jakarta Messaging API, formerly Java Message Service, or JMS API, is a Java application programming interface API for message-oriented middleware. It provides generic messaging models able to handle producer-consumer problem that can be used to facilitate the sending and receiving of messages between software systems. Jakarta Messaging is a part of Jakarta EE and was originally defined by a specification developed at Sun Microsystems before being guided by the Java community process. Here you can see the point-to-point message delivery mode. In this type of messaging, exchange of messages happen between a single sender producer and a single receiver consumer via a queue. Once the sender publishes a message, it is retained in a queue until a receiver consumes that message. This diagram shows this delivery mode, and here you can see client 1 is connected to message and it is send, and message is connected to queue, and here you can see the client 2 is connected to queue and consumes is passed from message 2 to queue, and acknowledges are passed from client 2 to queue, and this is messages consumed. Here you can see publish subscribe mode. Here we can have multiple receivers that receive the same message simultaneously, given that they have subscribed to the message broker via topics. When a message is sent, the topic publishes to all the subscribers and retains it until it is consumed. A subscriber can be durable or non-durable. The messages are stored persistently for a durable subscriber and can be recovered if the message broker fails. However, for a non-durable subscriber, the message are not stored, so no message is delivered if the consumer connection is lost. This diagram shows the publish, subscribe, delivery mode. Here you can see client 1 is connected to message, and message is message publishers, and message is connected to topic. Topic interact with client 2, client 3, and client 3. Delivers is passed from topic to client 2, and subscribes are passed from client 2 to topic, and here delivers are passed from topic to client 3, and subscribes are passed from client 3 to topic, and you can see the message here. Here you can see publish, subscribe, and point to point. Here you can see queue. Typical use cases, this is work distribution. Number of connected consumers allowed 0 or more. Who receive the message? Only one receiver. If no active subscribers, message persists. This is topic. Typical use cases: one-to-many broadcast. Number of connected consumers allowed 0 or more. Who receive the message? Who receives message? All active subscribers. If no active subscribers, message dropped if subscriber is not durable. Here you can see publish and subscribe one-to-many. This is publisher is connected to topic, and topic is connected to subscribers. Here you can see point to point, 1-to-1. Sender is connected to queue, and queue is connected to the potential receiver. Here you can see JMS queues in runtime cluster runtime instances. JMS can be used to achieve HA and FT by routing messages through JMS queues. In this case, each message is routed through JMS queue whenever it moves from a component to component. Pros are easy to do and well understood by developers. Cons requires a lot of transactions, and transactions can be complicated. And performance hit if you are using XA. Here the transport is connected to a inbound router via JMS, and transport is connected to JMS and queue, and queue is connected to inbound router. Inbound router is connected to queue. Again, queue is external queue, and queue is connected to service component, and service component connected to queue, and queue is connected to outbound router. Outbound router is connected to the queue, and queue is connected to transport. Here transport, inbound router, service component, outbound router, and transport are in Mule server in cluster. Here we are considering publish messages using JMS connector. Here publish message to a queue. In this example, you configure the operation to publish message to a queue specified in the destination field. In the JMS connector 1.8 Mule 4, Anypoint connector for JMS Java message service, JMS connector enables sending and receiving messages to queues and topics for any message service that implements the JMS specification. JMS is widely used API for message-oriented middleware. It enables the communication between different components of a distributed application to be loosely coupled, reliable, and asynchronous. The main features of JMS connector include the publish and subscribe pattern support on any given destination, listen and reply pattern support on any given destination, Publish and consume pattern support on any given destination with a fixed or temporary reply queue. Fully compliant with JMS 2.0, 1.1 and 1.0.2 specification. The publish operation publishes whatever it is in the message payload to the specified queue. Here you can see you configure the operation to publish a message to a queue specified in the destination field. Step 1, in your studio flow, select publish operation. Step 2, set the destination field to the queue name, for example invoice queue. With the here you can see step 2, set the destination field to the queue name, for example invoice queue. This is publish operation configuration to a queue. In the XML editor, the JMS publish and destination configuration look like this. As an example too, we can consider publish the message to a topic. The publish operation can also publish the message to a specified topic destination. Because all the configurations of the operation and message are identical, you just need only to configure destination type to topic. In this example, you configure the operation to publish a message to a topic destination. Step 1, in your studio flow, select publish operation. Step 2, set the destination field to the queue name, for example publish operation configuration to a topic destination. Image topic destination, the publish configuration is screen, set the destination type to topic. Here in the description there should be an image, and this is neglect this part here. Yeah, it's modified. And here you can see in the XML editor the JMS publish and destination type configurations look like this. As an example 3, we can consider add the connector to your Mule project. Add anypoint connector for JMS connector to your Mule project to automatically populate the XML code with the connector's namespace and schema location, and to add the required dependencies on the project's pom.xml file. This is under JMS connector 1.8 Mule 4. Step 1, in the Mule palette view, click search in the exchange. Step 2, in the add dependencies to project window, type JMS in the search field. Step 3, click JMS connector in available modules. Step 4, click add, and step 5, click finish. Adding a connector to a Mule project in Studio does not make that connector available to other projects in your Studio workplace. Now here we are considering JMS messaging support models in JMS connector Mule 4. JMS supports 2 models for messaging, point-to-point queues and publish and subscribe topics. Now we are considering configuring ActiveMQ connection in using Anypoint Studio to configure JMS connector 1.9 Mule 4 in JMS connector. uh, um, the JMS connector supports ActiveMQ5 by using ActiveMQ connection settings. With this connection, you can use JMS 1 default or JMS 10 2B specifications. You can also configure all general connection parameters for JMS as well as customer parameters present in your ActiveMQ. After you declare ActiveMQ connection, customize connection factory to your desired configuration. Every parameter in the connection comes with a default value, meaning that you are required to configure only the parameters relevant to your case. Also, ActiveMQ connection exposes parameters that are exclusive to ActiveMQ implementation, like initial delivery delay. In the following example, you configure the ActiveMQ connection. In the studio, navigate to the global element tabs. Click create. In the filter box, type JMS and select JMS config. Click OK. In the connection field, select ActiveMQ connection. In the factory configuration field, select edit inline. Set the broker URL here the you can see here the again in the factory configuration field, select edit inline and here, and set the broker URL field value to address of the broker to connect to, and for example here the for example the TCP colon ///////////////////////////////////////////////////////////////////////////////////////////////////////////////////////// click OK. Here the JMS connect ActiveMQ configuration. In the XML editor, the JMS active MQ connection and JMS factory configuration connections look like this. Here you can see add the namespace for the connector in JMS Connect XML, and Maven support Mule4 in JMS Connector. This example shows how the namespace LU statements are placed in the Mule XML block. Now we are considering increase concurrent messages. Increase concurrent messages processing in Tune JMS Connector for performance in JMS Connector. To improve the performance of your application, increase the number of consumers that receive messages from the same destination. JMS Connector enable you to increase the number of consumers by configuring the number of consumers field in the on new message source. By default, this source enables for consumers to receive messages concurrently in the same destination, but you can increase this number to the one that best fits your needs. In the following example, you increase the number of consumers receiving messages concurrently. In Studio, select on new message source from your flow, and in the on new message source configuration screen, set the number of consumers field to 20. Here the JMS connector number of consumers configuration here. In the XML editor, the number of consumers configuration look like this. Now we are considering enable verbose login for JMS connector. In enable verbose login in troubleshooting JMS connector Mule4 in JMS connector, Sometimes you are not sure why the application is failing, and you require better understanding of what is going on in the application interaction with the JMS server. To gather the details log, use the configuration file to increase the login level on the server side. Enable verbose logging for JMS connector. Access Anypoint Studio and navigate to the Package Explorer view. Open your application's project name. Open the source main resources path folder. Open log4j2.xml file inside the folder. If the following line is already in the log4j2.xml, uncomment the enable it or otherwise add it. And now we are considering default configuration in configurations in JMS connector reference 1.9 MuleSoft JMS connector. Here the parameter name, the name for this configuration, connectors reference the configuration with this name. Now we are considering configuring the connector in Mule3 example. In Mule3 example, in configuring the connector in migrating to JMS connector, in migrate connectors, in migration to Mule4, in Mule4 for Mule3 users in Mule runtime, moving from 3.x transport configuration to JMS connector configuration. Mule4 implies basically using the same exact parameter by declaring them in a more cohesive way. This means, for example, that the parameters that are used for consuming messages are declared in a consumer config group, while generating general authentication parameters are configured in the general group. Also, separation has been made between parameters that affect the behavior of the connector present in the config from those who affect the how connection is established present at the connection level. In the Mule3 example, configuring connector is here. In the same configuration, achieve Mule4 by the setting the same parameters in the context where they actually apply, like no local or durable, affecting only the topic consumer. Here the Mule4 example configuring the connector. Here the topic consumer. Yeah. As an exception example, we can consider this occurred in the environment with Mule server 3.9.0 and JBoss ActiveMQ server. org.mule.module.launcher deployment start exception, connect exception connection refused, connect at org.mule.module.launcher.application default Mule applications start caused by JMS caused by javax.jms.jms exception could not connect to broker URL. Reason java.net.connect exception, connection refuse connect, etc. As an error example, we can consider this one. The org.mule.runtime.co.internal.exception.onError propagate handler message. An error occurred while listening for the reply from the queue. Test queue failed to retrieve a message, operation timeout. Failed to retrieve a message, operation timeout, and error type JMS :timeout. This is the element here, and other informations are here, and etc. Now we are focusing on file. A computer file is a computer resource for recording data in a computer storage device, primarily identified by its file name. Just as words can be written to a paper, so can data be written to a computer files. Files can be shared with and transferred between computers and mobile devices via removable media networks or internet. Here you can see a single segment in flat file schemas. If you are only working with one type of record, you only need to have a segment definition for that record type in your FFD. Here the composite is there, and elements are in composite, and again composite and elements are in segment here. Here you can see multiple segments. If you are working with multiple types of records in the same transformation, you need to use a structure definition that control how these different records are combined. In most cases, you need to define a way to distinguish between different types of records. You do this by identifying tag value fields as part of the record definitions. The parser will check the content of the fields of each record to identify the record type and then see how it fits into defined structure. Here you can see composite and elements are in composite, and composite and elements are in the segment, and this is one segment and this is another segment. Here you can see multiple structures. If you have multiple structures or segment definitions in an FFD, when you apply your schema to a metadata description on the transform component, you need to specify which one you want to use. Here you can see a group and segments are in the group here, and here the composite and elements are in the composite, and composite and elements are in the segment here. Here the group and segments are in the group, and group and groups, and here the segment are in the structure, and there are other. This is one structure, this is another structure here. As an example, we can consider this one. This example read file using file configuration and relative path. The file connector 1.5 Mule 4 anypoint connector for file connector manages files and folders on a locally mounted file system. The connector's main features include ability to read files or fully list directory contents on demand, support for common file operations such as creating directories, reading, writing, copying, moving, renaming, deleting, and listing files, support for locking files, file matching functionality, design that is consistent with FTP connector and SFTP connector. Using anypoint connector for file connector, the transport can read a file at any point in the flow rather than only as a result of inbound endpoint polling in the Mule 3 implementation. The only required parameter for the read operation is the path to the file to be read. The path can be either full path to the file or relative path. The path uses the working directory value defined in the configuration reference by the config-ref parameter. In Anypoint Studio, you can set the path in the file path field, and XML use the path attribute file read statement to specify the path. If no configuration is referenced, the working directory default to the value of the user.home system property. If the system property is not set, the connector fails to initialize. This example reads a file using the file configuration and relative path. Here, this is example. As an example, we can consider this. This is in data view. This uses read URL to read JSON content from your file. DataWave 4.4 here. DataWave is a programming language designed by MuleSoft for accessing and transforming data that travels through Mule applications. Mule runtime engine incorporates DataWave in several core components like transform and set payload, and which enables you to execute DataWave scripts and expressions in your Mule app. As an example 3, we can consider using Anypoint Studio to configure file connector 1.5 Mule 4 at the connector to your Mule project, at the file connector to your Mule project to automatically populate XML code with the connector's namespace and schema location, and add the required dependencies to the project pom.xml file. Step 1 here, in the Mule palette view, click X search in the exchange, and in the add dependencies, step 2, in the add dependencies to project window, type the file to search field, and in step 3, click file connector in available modules, and step 4, click add, and step 5, click finish. As an example 4, we are considering class file utils. File utils contains file utils in org.mule.runtime.core.api.util. File utils contains useful methods for dealing with files and directories. Now we are considering representation of file in Mule file connector Mule 4. Mule 4 provides the message structure of a payload and attributes which are the data moves around, making that payload file content. Attributes provide the object that contains metadata of the payload and the information such as file name, path size, timestamp, FTP connector, and SFTP connector. These attributes are named file attributes. Mule message specifies the encoding and MIME type, which describe the format in which the payload is represented. File attributes describe the file's encoding of and MIME type. Now we are considering configure a global element for the connection in using Anypoint Studio to configure file connector 1.5 Mule 4 in file connector 1 Mule 4. When you configure a connector, it's best to configure the global element that all instances of that connector in the app use case apps can use. Configuring a global element requires you to configure FTP server connection. To configure the global element for a file connector, follow the steps. Select the name of the connector in the Studio canvas. Select the operation in the Studio canvas. In the configuration screen for the operation, click the plus sign next to the connector configuration field to access the global element configuration fields. In the General tab, specify the connection information for the connector. Set the working directory as the root of every relative path used with this connector. If it is not provided, the value default to the value of the user home system property. If the system property is not set, connector failed to initialize. Set the host to specify the FTP server host, for example localhost 192.168.0.1. In the advanced tab, optionally specify the timeout configuration and reconnection strategy, and in the click test connection to confirm that Mule can connect with the specified server, and click OK. In the configuration XML editor, configuration file config look like this. Now we are considering add a namespace for the connector in file connector XML, and Maven support Mule 4 in file connector. This example shows how the namespace statement applies in the Mule XML block. Now we are considering read the file using file connector in file connect example Mule 4 in file connector. Using Anypoint connector for the file connector, the transport can read the file at any point in the flow rather than as a result of inbound endpoint polling in the Maven 3 implementation. Only required parameter for the read operation is the path to the file to be read. Path can be either full path to the file or a relative path. Path uses working directory value defined in the configuration, referenced by the config ref parameter. In Anypoint Studio, you can set the path in the file path field. In XML, the path attributes in the file read element to specify the path. If no configuration is referenced, the working directory default to the value of the user.home system property. If the property is not set, the connector failed to initialize. The example reads a file using file configuration and a relative path. This example, read the file using a full path. In Studio, click the browse button to locate the file. For example, uses my file. In XML, use the path attribute to specify the path to the file. For example, path uses my file. Now we are considering troubleshoot Mule application issues in troubleshooting Mule file connector Mule 4 in file connector Mule 4. Sometimes you are not sure why the application is failing and you require a better understanding of what is going on in the app's interaction with the file system. To resolve this error, use configuration file to increase the logging level on the server side. Try to replicate the issue using a file client, for example CyberDuck or FileZilla. If the issue also occurred in these clients, then it is likely that the issue is not related to the Mule app. It's better get better and more detailed logs on the Mule app side by enabling verbose logging for file connector for JSCH driver. Access Anypoint Studio and navigate to Package Explorer view. Open your application's project name. Open source main resources path folder. Open log4j2.xml file inside the folder. If the following line is already in the log4j2.xml file, uncomment it to enable it, otherwise add it. Add the following argument to run the configuration. Try to minimize or remove unnecessary data view transformations. You could even use hard-coded data to minimize the app's complexity and determine whether the issue is with the interaction between the app and the file system. For additional information about enabling verbose logging for SDK component in the Mule application, see the troubleshooting SDK component in the documentation. Now we are considering default configuration. In configurations in file connector refers Mule 4 in file connector Mule 4. This is a parameter name here. The name for this configuration, connectors reference the configuration with this name. Now we are considering copy file, the file in file operations in toolbox in RPA build in RPA. This section step copies a file from one directory to another. If the file to be copied, if not available, or copied file is already located in the destination folder, an error message will interrupt the workflow. Now we are considering create file in file operations in toolbox in RPA build in RPA. Create file is used to create an empty file at the specified path. Now we are considering delete file in file operations in toolbox in RPA build in RPA. Delete file will delete the file located in the specified path. Action step can be used, for example, to delete files which are generated within the workflow. If the file for deletion does not exist, then the action step does not terminate the workflow into an error. There is, however, an option that enables the generation of an error message in the event of non-existent file. Now we are considering file operations, extract images from PDF file in file operations in toolbox in RPA builder in RPA. With this action, you can extract images from a PDF file. Now we are considering file check in file operations in toolbox in RPA builder in RPA. File check action step allows you to check whether a file exists or not. You can evaluate result using file check, file select succeeded variable, and use it in the larger stages of the workflow. Now we are considering get file info in file operations in toolbox in RPA builder in RPA. Get file info fetches information about the file at a specific path, and you can retrieve the following information: date created, date modified, owner, when the file was last accessed. The information fetched is saved in the appropriate variable for further processing. Dates are written in UTC, coordinated universal time formats as follows: YYYY mm-dd THH:mm:SS Z. Now we are considering iterate over files in file operations in toolbox in RPA build in RPA. The iterate over files action step perform various action steps on a specified number of files. Drag the action steps to be accessed. Drag the action step to be processed into the gray area labeled drop items here using a drag and drop. The action step placed there will be processed from top to bottom in the order specified. This means that action steps for processing will be applied to all files located in the folder depending on the settings, its subfolders. It is possible to set various parameters such as maximum number of files to be processed. Now we are considering move file in file operation in toolbox in RPA build in RPA. This action step moves the file from one directory to another. If the file to be moved, if not available, or moved file is already located in the destination folder, an error message will interrupt the workflow. Now we are considering read from a text file. In read from a text file in file operation in toolbox in RPA build in RPA. Read from a text file action step allows you to read from a text file and use the read mode to specify which part of the file is to be read. The button in the workflow, the read mode that is presently active in the brackets after name of the action step. In the example above, whole life, there is an option to determine whether the text should be deleted after reading. Now we are considering read PDF file in file operation in toolbox in RPA build in RPA. With the read PDF file action step, you can read the text from the PDF file. Now we are considering rename file in the file operation in toolbox in the RPA build in RPA. This action renames a file, and if it's a file, if the rename file already exists in the destination folder, workflow is interrupted in the error message. Now we are considering write to a text file in the file operation in the toolbox in the RPA build in RPA. Write to a text file, write to a plain text file with the .txt as the only support file format. You can specify if you want to write to text file or overwriting existing text in a file or create a new file. Now we are considering import a file or a content of a zip file that is stored in your computer if you are using a text editor. In procedures, in import file into an API fragment project in API design in design center. Click the gear icon in the top of left top right corner of the next editor and select the import, and then select in the import dialog select file or zip. Now we are considering file multipart in dw module multipart in data view reference in data view. This is the file. This is file and name, path, mime, and file name. Create a multipart data structure from a resource file. This version of file function accepts as argument an object containing key value pairs, enabling you to enter key value pairs in any order, for example here. Now we are considering read from Excel file in Excel operations in toolbox in RPA. Use the read from Excel file action step to read the content of an Excel file. The result will be saved as a string or an array, which you can use as an outbound variable in subsequent action steps. The read from Excel file action step can only be used inside an Excel session. Now we are considering recalculate Excel file in Excel operations in toolbox in RPA. Recalculate Excel file action step can be used to recalculate an Excel sheet. If the value has subsequently changed, the values in the Excel sheet are updated. To be able to continue working with the new values, they must be read out with the read from Excel file action step. With the action step recalculate action file, you can determine exactly where the recalculation should take place in the workflow. Recalculation is documented in the workflow result. Read from the Excel file action step can only be used to inside the Excel session. Specify the source and destination file in the Excel session. Please note that operation mode that you have selected in the Excel session, read and write to the same file. The recalculation is performed on the selected Excel sheet. Read from the source and write to a different file. Recalculation is only performed in the selected destination file. Read only, the action step cannot be executed in read only mode. Now we are considering save Excel file in Excel operations in toolbox in RPA. Use the save Excel file step to save the changes to the Excel file being modified inside the Excel session in any point of the execution. For example, saving Excel file after loop operation serves as a way to prevent lost data in case workflow execution is stopped because of an unknown error. Excel session automatically saves the file at the end of this execution. The save Excel file action step works only inside an Excel session. Specify file to modify the Excel session. Save Excel file cannot save the file if the Excel session opens the file in read-only mode. Now we are considering write to Excel file in Excel operation in toolbox in RPA. Use write to Excel action step if you want to write the content you have read from the Excel file using read from Excel file action step either to same or different destination file. The write to Excel file action step can only be used inside an Excel session. Specify the destination file in the Excel session. Now we are considering imported configuration files in modularized configuration file in common development strategies in best practices in develop Mule applications in Mule runtime. Mule has special import component for importing configuration file into other files. This component takes a file parameter which contains the reference to the desired configuration file. The other example, this following example shows a main configuration file that imports 3 other configuration elements. Global dash configuration, admin dash config, global dash global configuration.xml and admin config.xml and audit flows.xml here. Now we are considering single segment in file flat file schemas in language guide in data view. This is a simple schema with only one segment. The example above simply define list of elements within single segment. It has no composites to group them into. Here is another example. Note that simplified forms are only for convenience. You can use the segments key even if you only have a single child segment definition. Now we are considering distributed file pooling in advanced Mule concepts in Mule runtime. Some connectors such as a file connector or FTP connector poll directions directories and read certain files as they are created in directory polled. These files can reside on a remote file system, including file systems of nodes belongs to a Mule high availability HA cluster. In Mule 4, distributed file pooling makes it possible to pool files in all cluster nodes. Enabled by default, this feature is used by the following connectors: file connector, FTP connector, SFTP connector. You can configure connectors to only pull from the primary node at primary node only, which ignores the default setting set by the Mule runtime engine. This feature is only available in Mule 4.x. Now we are considering catalog descriptor line in creating or updating descriptor files manually in cataloging auto catalog API using API catalog CLI in Exchange. The description file must start with the following line. The description version corresponds with the version of the API catalog CLI that you are running. The following example shows the required starting line for API catalog CLI 1.0.0. Now we are considering importing a file at a design time in file control loop, in file control, in glossary, in RPA. When you select a read file now, the wizard shows the following configuration options. Click import file to select the file to import. RPA builder then reads and analyzes the file and displays the content preview in the file content preview section of the wizard. The file content preview section enables you to apply filters to each column by clicking the filter button. When you enter the text in the filter field, preview the filters out all rows that do not contain the specified text. Select use regress to use regular expression instead of plain text when applying filters. You drop down next to each column name to change the type of column content. Now we are considering migrating file connector. File connector in migrate connectors in Mule4 for Mule3 users in Mule runtime. In Mule3, all transport configurations are set under the top level element called file::connector. By default, the file connector sets auto deletion, streaming, and validation of the connector to true. Here is the Mule3 example default file configuration. The connector configuration also provides the settings for reading, writing, and moving files among many others. The next example shows the most of the three Mule3 settings available in the file connector here. Here the Mule3 example available file connection settings here. In Mule4, the file :config is the top level element for the connection configuration, and file::connection is the child element for the connection related settings. Here the Mule4 examples. The working dir allows to specify the path to which the all other paths are relative to. If not specified, the user home directory will be used. Note that the Mule3 work directory is used when moving in input files before processing them. Default write encoding identify the character encoding to use for writing. You can override this global configuration with the file operation such as write. All other Mule3 config parameters are no longer needed since they were either replaced by parameters in the new connectors operation, so they were rendered needless by the new connector model. Now we are considering the default root file in root files in API specification projects in text editor, in root files in projects in the text editor, in the API designer, in API design in a design center. When you create API specification project, file that is created by the default is set to be the root file. Here the the name of the RAML API specification project is orders API. Here for example, here the default file which is named orders-api.raml and is set as the root file because every API specification project must have the root file. Here you can see move transformation to separate files in transform message component in Studio to export the data view code to a .dwl file, click on the edit current target and select file radio button. And type the name for your .dwl file and click OK. Here now we are considering edit to API specification project exchange file in API sync in Studio. To edit to exchange .json file, select it from your API specification project in your project explorer view, and use the editor to update the values of your exchange.json file. Now we are considering add policy implementation files to publish policy definition in publish assets in Exchange. When a policy definition asset is published in Exchange, the asset details page displays the pending flag next to implementation. In the left navigation bar, the flag indicates that the policy implementation has not been added. Add the policy implementation files to the policy definition to enable the policy to be available in runtime. Required implementation files are binary such as WebAssembly, WASM file for Flex Gateway, or jar file for Mule for runtime, and YAML metadata. Before adding the policy implementation file, ensure that the policy definition asset is the stable state. To add the policy implementation file in Exchange, select the policy asset to open the asset dev details page. Click the implementation in the left navigation bar. Click add implementation. Enter the name for the implementation. Choose file. Click choose file to select the jar or WebAssembly file. Click choose file to select the YAML file. Click edit to edit the group ID, asset ID, version, and API version. Click advanced and click advanced. Exchange generate a group ID, asset ID, and version. You can change these values. You can also change the API asset version and API version separately. The advanced settings are most often used to change the asset version. Click add implementation. The implementation displays in the manage implementation table. From this table, manage implementation versions of the policy asset. See the manage versions for more information in the documentation. Here you can see Mule transformation to separate files in Anypoint Studio in Mule runtime 4.5. By default, data view code for transform message component is expressed inline within your Mule XML file. You can instead keep each in a separate file .dwl, and you have your XML reference them. These files are packaged with your Mule application when built. To export the data view code to a .dwl file, click edit current target button here, and select the file radio button. Type a name for your DWL file and click OK. File is created under source main resources folder in your project containing your data view code. Add policy implementation files to published policy definition in published assets in Exchange. When a policy definition asset is published in Exchange, the asset details page displays the pending flag to the implementation in the left navigation bar. The flag indicates the policy implementation has not been added. Add the policy implementation file to the policy definition to enable the policy to be available in runtime. Required implementation files are binary files such as WebAssembly, WASM file for the Flex Gateway, or jar for Mule for runtime, and WAML metadata file. Before adding the policy implementation file, ensure that the policy definition asset is in the stable state. To add the policy implementation file in Exchange, select the policy asset to open the asset details page. Click implementation in the left navigation bar. Click add implementation. Enter the name for implementation. Click choose to select the jar or WebAssembly file. Click choose to select the YAML file. Click edit group ID, asset ID, version, and API version. Click advanced. Click add implementation. API catalog create descriptor in create a descriptor file, creating or updating descriptor files using the CLI, auto catalog API using API catalog CLI, API catalog create descriptor. This command accepts the following tags: d file equal file, the default catalog.yaml, the name and location in which you to save the generated descriptor file, -- external, generate an exchange.json file for each API described in the descriptor file, and add the reference to each of these descriptor your file using ref tag in the project select section. To create a descriptor file using CLI, navigate the directory path that contains the API you want to catalog. Run the API catalog create descriptor command. Following example, create a descriptor file called mydescriptor.yml in the current path. Example output that is written to the descriptor file is here. If you are using -- external flag in an external extend.json file is generated for each of your APIs, and descriptor file has references to each of those shown in the following example here. Example output that is returned to the descriptor file here. Projects here in presence and contents of designated descriptor file affect the result of the command as follows: no file or empty file. The command discovers the API and writes its result to the standard output and to the file name catalog.yml. If the existing file with the content, command failed and shows an error message that says the descriptor file already exists. Now we are considering example of reading a flat file. In read and write a flat file mule in data view examples in data view 2.5. The following example application consists of a scheduler component that triggered the flow, a file read operation that read the flat file from the specified path, and a transfer message component transform the content read from the flat file to JSON format, and logo component that outputs the current payload. Here the application.xml file and section of application.xml file. Note that the file read operation configure the following attributes. A path to the flat file to read. Output MIME type. Output MIME type document content of, in this case, application/flat file. Schema path refer to the property that specified the path to flat file schema.fd file. After the execution, the example application generates the following output here. And this is section of the output. Here you can see the procedure in create and publish an API specification of fragment from an external file in API design in Design Center. In the project page Design Center, click the create new button and click the import from file. Specify a name to specify a name to give to the import project. Click choose, then browse your file system for you want to import. You can create a new project from the following file type: JSON, RML, YAML, a zip file that contains an existing project. Click import as, then choose either API specification or API fragment. API designer opens the API specification or fragment in the new project using a text editor. API designer uses the existing file name, or for each file of the project you can change these names as necessary. Now we are considering configure the read operation in Studio in read the file using SFTP connector example mule4 in read the file in SFTP connector 2.0 and SFTP connect examples. To add and configure read operation in Studio, follow these steps. In the Mule palette view, search for SFTP and select the read operation. Drag the read operation into the Studio canvas. In general tab, of the operation configuration screen, click the plus sign next to the connector configuration field to access the global element configuration field. Specify the connection information and click OK. In the general tab, set the file path field to the path of the file to read, for example hash path. In the advanced tab, set the MIME type field to application/XML and the encoding field to ISO 10646/Unicode UTF-8. Following screenshot shows the read operation configuration. In the XML editor, set up in the SFTP :read configuration look like this. Here you can see import API specifications in Studio 7.15. Import and specification from the local file. Here it is not possible to add the local API specification to an existing Mule project. In the taskbar at the top of the AnyPoint Studio display, select File, then New, then Mule Project. Type a name for your project. Select the Mule runtime engine version. In API specification section, select from Designer Center or Local Files tab. In the location field, type a location of your local API. You click the button and select Browse Files. You can import either RML file or an entire .zip file bundle if your API has schemas and example, and click Finish. The Mule configuration file in Mule runtime 4.5. Following is an example of a sample Mule configuration file for an application. And this is segment. Here the example specify flat file schema in flat file format in supported data formats in data view 2.5. This example shows the data view script that outputs the data in a flat file format. It uses the schema path and the structure indent writer properties. Here you can see a configure archive operation in archiving and extracting files in compression mode 2.2. Given an input stream payload, archive operation enables you to compress all the payload entries into a new archive file in the zip format. The operation received a map and then identify the values to compress. Then the operation received an entry which is placed inside the compressed archive file with the entry name you provide in the data view compression. In Studio, drag the archive operation into your flow. Insert entries data view script defining each name of the entry compressed as the key and the content of the entry as its value. In the configuration.xml editor, configuration look like this. The resulting archives contain the three entries: summary.pdf located at the root level, and result_001.pdf and result_002.pdf located in the details directory. Note that the slash forward in the same of the entry name of the entry, for example details for set result_001.pdf, indicates the directory operation. All names are introspected to create directories inside the archive. If you create the input to archive operation using data view expression, the data view expression must output an object used to build the Java map object. Define unique keys to add the entire object to the archive. Here the create Mule application in inserting large file content into table in database connect examples in database connector 1.14. Follow the steps to create the Mule application. In Studio, drag the HTTP listener source to the canvas. Click the plus sign next to the connector configuration field to configure the HTTP global connection. Configure the HTTP global connection and click OK. Set path to read insert. Drag the logo component to the right of the HTTP listener source. Set message to starting large club reading. Drag the file connector read operation to the right of the connector logger component. In the general tab of the operation configuration screen, click the plus sign next to the connector configuration field to access the global element configuration field. Set working directory to /directory /containing /files/ to read the file property. Click OK. Set file path to awesome file.json. In the MIME type tab, set MIME type to application /octet stream. Drag another logger component to the right of the read operation. Set display name large club content on flow. Drag the database connector insert operation to the right of the second logger component. Click the plus sign next to the connector configuration field to configure the database global connection. Configure the database connection and click OK. Set the SQL query text to insert auto awesome club data values payload. The SQL text insert a new record with that file content in the tab. Set input parameters to expression. Drag another logo component to the right of the insert operation. Set display name to large club content inserted. Here the SQL text insert a new record with the file content in the table. Here input parameters here, and drag another logo component to the right of the insert operation. Set display name large club content inserted. Set message to the compression payload. Save and run the Mule applications. Test the app using the following curl command in your terminal: curl localhost 8081 /read-insert. Configure the read operation in Studio. Read file using FTP Connect example in FTP Connect examples and FTP in FTP Connector 1.4. To add and configure the read operation in Studio, follow the steps. In the Mule palette, search for FTP and select read operation. Drag and read operation into Studio canvas. In the general tab of the component configuration screen, click the plus sign next to the connector configuration field to access the global element configuration. Specify the connection information and click OK. In the general tab, set file path to path of the file to read the for example hash path. In the MIME type tab, set MIME type application /XML in and read and set encode into ISO 10646 /Unicode UTF-8. In the configuration XML editor, the FTP :read configuration look like this. Order property in policy tag. Configuration and definition file in the difference in custom policies in Mule 3 in Mule Gateway. You can set the order execution policy using order property. However, settings in order policy execution in a message processor takes procedure over settings order or the order execution of the policy tag. Set the order to integer greater than 2 because the order values 0 to 2 are reserved for cost, throttling and rate limited parameters. Respectively, these policies must execute before others. Following example show how to set order property in policy tag. Here we are considering steps to follow in Flow Designer. In deploy a Mule application from Runtime Manager to Cloud Hub by using your Java file. In deploy a Mule application in Flow Designer in Design Center. Ensure that the project is free of errors. Export your project by clicking the three dots in the top right corner of the canvas and select export. Three dots are to the right of the button that is labeled within a down arrow. Export option is at the bottom of the menu. Select export Mule application and click export. A jar file containing a copy of your Mule app is downloaded to the default location on your computer. Now we are considering configure compress operation in compressing and decompressing a single file in compression module 2.2. Given an input stream payload, compress operation enables you to compress the stream and return a new compressed stream of bits. You can then store the compressed stream of bits in a file system or transfer it to another system. In Studio, drag the compress operation to follow. Set content to your input stream payload to compress. Set compressor to gzip compressor or zip compressor strategy. In the configuration XML editor, configuration look like this. Here you can see a lookup data in an XML Excel XX files in DataView examples in DataView. This DataView example uses a filter function to return only the rows of an XM Excel SX file. Input input file that contains a specified value. Before you can begin, note the 2.x versions of the data view are used by the Mule 4 apps. For data view in Mule 3 apps, you refer the data view version 1.2 examples in the documentation. For other data view versions, you can use the version selector in the data view table of the content. By default, the files over 1.5 MB are stored on a disk. Smaller files are stored in memory. Following data view script reads the Excel SX file and returns the filtered data from it. It assumes that its spreadsheet name ourbugs.excel SX contains the data on the bugs assigned to the all members of the team, including a assignee named Fred M. Data view script is here. The script passes class path colon ourbugs class path colon / ourbugs dot excel sx application / excel sx output application / json. My input dot data filter entry index entry dot assignee / freddem. Script the script passes for class path colon ourbugs dot excel sx to the read URL function to read the file from the Studio project directory source main resources. It shows the result in the data view my input. The script selects the sheet named data from the Excel SX file, then filters out all records except one where the assignee columns contain the value Fred M. It returns the result in an array of JSON object, for example here. Using the same data view script in this previous example, next example writes the result to the filter for expression to a file fredbugs dot JSON, the example is the configuration XML from my project in the studio. The XML configuration in studio is like this. The scheduler triggers here the triggers the flow to execute the next component transform message. The transform message component transform provide the data view script to return all records from data sheet for which the assignee column contains the value Fred. And transform the binary Excel SX input to JSON output. The write operation, the write operation file write from the file connector received the JSON payload from the E transform and write it to the file called fredbugs.json. Now we are considering set passing text file attachment as body language body message in email connector email connector 1.7. When endpoint connector for email connector receive the message without a body and only an attachment file with content type as text, the attachment file is not processed as separate file. Instead, the file is included main message body as plain text. Mule apps can use this behavior to receive the data in the message body instead of as an attachment file. To change the behavior of passing attachment text file when the file is in the only content in the message, set system property passing.text.attachment.as.body to either of these values. True default pursue the previous behavior and convert the text file attachment in the body message. False add the attachment text file to the attachment list in the payload. To learn how to set system properties in Anypoint Studio or for an on-premises deployment, refer to system properties documentation. Now we are considering export app data to a CSV file use data dashboards in monitoring. Built in a custom dashboards, you can export app data to your CSV file, which you can use in other application. Data export works on individual chart level, so only data in the specified chart is exported. When you apply a filter to a dashboard, the exported data includes only the data included in the filter you set. For example, if you apply the time period filter, only the data for that time period is exported. This feature requires a Titanium subscription. Log into the endpoint platform. In the navigation bar or the main endpoint platform screen, click monitoring. In the endpoint platform monitoring navigation menu, click the built-in dashboard or custom dashboards. Select the application for which the download the data. Specify the time range for data to download. In the chart containing the data in the data and containing the data to download, click the three vertical dots in the top right of the chart and select export CSV. In the export CSV dialog, specify the way to format the data. In the mode, select the format for the data. Series as rows, format the data in rows in the CSV file, for example, and series as columns, format the data as the columns in the CSV file, for example. And in datetime format, enter the values to specify the datetime format, for example, YYY, MM, and then DDT, HH, then MM, SSZ. Click export. The CSV file download automatically in the browser. Now we are considering source in the now we are considering an example in the multipart file in mod example in dw module multipart module multipart file in data view reference in data view 2.4. This example create a multipart part from the file accessible to the data view function. The file name is orders.xml and is located in the Mule application / source main resources. The file function locates the external orders.xml file and uses the key value pairs to indicate the various parameters needed to build the multi-part part. The name can be anything, but usually coincidence the required parameters needed by the receiving server that accept the multi-part payload. Path is set to dot orders .xml, which is the path and name for the orders.xml. The file is located on the multi-part part. The MIME parameter specify the correct MIME type for the file. In this case, it's application /xml. The file name can be changed to any value. It can be different from the actual input file name. Note the output of this example is not compatible with the multi-part /form data of this example is not compatible with the data and output type because of it's just one part of the multi-part structure. Create a valid multi-part form data output. Use the multi-part : form function with one or more multi-part files and or fields. Source this is the source and the input the file called orders.xml located in the source main resources with the following content. This is the output. And here the etc. here is going like that. And etc. Now we are considering lookup data in CSV file Mule in data view examples in data view 2.5. In this data view example uses the filter with map to look up the CSV file and return the country code for each calling code found in the input array of the phone numbers. Before you begin, note that 2.x versions of the data view are used by the Mule 4 app. For data view in Mule 3 apps, refer data view version 1.2 examples in the documentation. For other data view versions, you can use the version selector in the data view table of contents. Following JSON payload is provided as an array of phone numbers into the data view script. The value in the variable country codes is a CSV file that maps the coding codes to the country codes. The following data view script reads the each phone number in the payload and uses the filter function to search for calling code within the Mule variable country code that matches the calling code in the phone number. And then the map function gets the country code that correspond to the calling code and returns the result to the array of JSON objects. Correspond to calling code returns the result to an array of JSON objects. The data view script is here. The sample output is in JSON here. Now we are considering properties in read from text file in file operations in toolbox in RPA Builder 6.2. Delete lines after read the file operation here. I specify whether the text should be deleted after it is read. As an exception example, we can consider this one occurred in the environment with file connector. org.mule.api.default mule exception failed to move file source file to destination file. The file might already exist. As an error example, we can consider throw file colon illegal underscore path in the environment with file connector. This is the create parent directory property is set to false, and neither the target path nor its parent exist. This is the end of my presentation. Thank you very much for watching it.